In this section, we will continue learning important JavaScript fundamentals. And so that means that we will learn the basics of functions, objects, arrays, and also loops. So after this section, you will already have a good foundation to start writing your own small programs using the power of JavaScript. And I hope that sounds super exciting, and so let's get started. Now, before continuing to learn JavaScript in this new section, we should first activate a special mode in JavaScript called strict mode. And here on my desktop, I already have the folder for this Part 2 Fundamentals section. And for you, as I explained before, these starter files will come from the GitHub repository that I showed you at the beginning of the course. So use that GitHub repository as your starter folder, or of course, you can just copy that data somewhere else to your computer and work from there. Whatever works for you. Now I'm creating here a new VS Code window. And let's open this new folder. So that's our new working folder. And this time we already have the script file here. And in the HTML file, we see that the script is also already linked. So we don't have to do that this time. At this point, I assume that you already know how to do that. So closing the sidebar here, and let's now get started in this new section. And as I said, let's start with strict mode. So strict mode is a special mode that we can activate in JavaScript, which makes it easier for us to write secure JavaScript code. And all we have to do to activate strict mode is to write this string at the beginning of the script. So use strict. And that's it. So with this, we activated strict mode for the entire script. Now what's important is that this line of code, so this statement here basically, has to be the very first statement in the script. So if we have any code before this, then strict mode will not be activated. Comments are allowed because JavaScript will just ignore them, but no code. Okay, now we actually can also activate strict mode only for a specific function or a specific block, but I don't really see the point in doing that. And so I always just use it at the beginning of each script. And so I believe that you should do the same. So always just put strict mode in the beginning of your scripts, and like that, write more secure code. And with secure, I mean that strict mode makes it easier for us developers to avoid accidental errors. So basically, it avoids us to introduce bugs into our code. And that's because of two reasons. First, strict mode forbids us to do certain things. And second, it will actually create visible errors for us in certain situations in which, without strict mode, JavaScript would simply fail silently without letting us know that we did a mistake. Okay? So again, first, strict mode forbids us to do certain things. And second, it creates visible errors in the developer console, where in other situations, JavaScript would just fail silently. Okay, but now to make this a bit more clear, let's actually see an example of one of the most important changes that strict mode introduces. So let's create a variable here with a complicated name. Let's say has driver's license. And let's initialize it to false here. And then I also will create pass test and set that to true. And I'm using let in both of them because I want to change them later. And actually this one not. So let's just use a const here. Because remember, by default, we should always use const to avoid accidental errors. So basically there is a certain person which right now does not have a driver's license, but they just passed a test. That's why we have pass test set to true. And now we want to write some logic so that when they pass the test, this variable here gets set to true. So we can say if pass test, right? because this here is a Boolean value. And so this condition will be either true or false. And then let's introduce a simple bug here. Okay, so this is a kind of hard to write variable name. And so let's pretend that we are writing it wrong here. So has driver license equal to true. So what I did here was to basically omit the S. So this letter here is not in this variable that I'm trying to change here to true. And again, that is an error that I'm making here on purpose, just to show you how strict mode can help us avoid a certain kind of error. Because doing this is actually more common than you might think, okay? And now, then let's log something to the console if the person has a driver's license. And so now we're actually gonna go back to writing it correctly. So if has driver's license, and so you see that now this one is exactly the same as VS Code highlights both. So if has driver's license, then log to the console, I can drive. And now let's actually start by deactivating strict mode again, just so we see how this bug could affect our code. So I'm giving it a save, and then let's go and open this index.html file. Okay, now let's open up the console here. And again, I'm going to increase the text by hitting Command plus a couple of times here. Okay, so let's reload here just to make sure that everything is working. And now what we see is that it didn't log I can drive to the console, even though we attempted to set has driver's license to true here. And so we expected that driver's license being true should then log I can drive. But it didn't work. And that's because of the mistake that I just introduced here on purpose for getting this S. So without the error, it should work, right? But without it, it's not gonna work. And again, because basically here I set a new variable to true and not the original one. So this one is still false, and that's why here this logging does not happen. So now our program has a bug, which means that it has a mistake, and we would now go ahead and find that bug. But strict mode can actually help us with this. So let's turn it back on, give it a save, and now try it again. And now we actually get an error. So here we see that has driver license is not defined. So in line number 6, which is right here. And so this error message now tells us exactly what is wrong. So it tells us that this variable is not defined. And then we can see, oh, we did a mistake here. We're missing the S, right? So now it's the same variable here, here, and here, okay? And so if we try that now again, then the error is gone. And so strict mode really helped us avoiding this kind of bug that we created here. And you can experiment a little bit with this to make it really clear. Now, another thing that strict mode does is to introduce a short list of variable names that are reserved for features that might be added to the language a bit later. For example, let's try to define a variable called interface. For example, for an audio interface. And now if we try this, then we see that we get an unexpected strict mode reserved word error message, basically. And that is, again, because JavaScript is reserving this word here for a feature that it might implement in the future. And so by reserving this kind of words, it will then make it easier to implement the feature in the future. So another one is private, for example. So const private, just some number here. And so this one will also not work. And that's because in the future, there might be something called private fields in classes or in some other places, even in the language. And they might want to use this word for that. And so strict mode reserves these words so that we cannot use them for variables. It's the same logic as this one. So we cannot call a variable if, right? And that's because there is already an if statement. So here we get unexpected token if. And so that's like the rules that I explained to you in the beginning about naming variables. Okay. All right. Now there are actually a lot of other changes that affect things that we haven't learned about yet. So that's stuff like functions, objects, setting properties on primitive values, and many more. And I will mention them in future lectures when the time comes. But everything that I'm gonna say in the rest of the course from now on will always assume that you have strict mode turned on. And so I will add this line of code here to all the scripts in the future, and so you should do the same. Anyway, with this out of the way, let's now start learning functions. The fundamental building block of real-world JavaScript applications are functions. They are one of the most essential concepts in the language, and so let's study functions over the next couple of videos. So, what actually are functions? Well, in the most simple form, a function is simply a piece of code that we can reuse over and over again in our code. So it's a little bit like a variable, but for whole chunks of code. So remember, a variable holds a value, but a function can hold one or more complete lines of code. So let's now declare our very first function. So we start with the function keyword, and then we define a function name. And let's now just create a simple logger, which is a function that will simply log something to the console. So I will call this one logger, and then we need parentheses, and we will see why in a next example. And then we use the curly braces to create the so-called function body. So all the code that is within this code block here, so within this block of curly braces, is called the function body. And it's this code that will be executed when we run this function. So let's say we needed to execute a log many times somewhere in our program. So let's simply console.log. My name is Jonas. And so somewhere in our program, we needed to reuse this line of code here multiple times. And so that's why we put it in a function. Okay? So we created the function, and now we can use it. And we can use it as many times as we want. So to use the function, we simply write the function name followed by parentheses, and that's actually it. And this process here of basically using the function is called invoking the function, running the function, or calling the function. So let me actually write these terms here. So calling, running, or invoking the function. And you will see me use these three terms here interchangeably. Okay, so they basically mean the same thing. You can think of them as like executing or using the function that we defined previously. Okay, and as I said, we can now use or call or run this function as many times as we want. And each time that we call the function like this, then the code that is in the function will get executed. All right, so in this case, what should we expect here? Let's see. And indeed, we get this my name is Jonas log 3 times because we called the function 3 times. And so this line of code here was executed 3 times. Great. So we just wrote our very first function and it's already working just fine. And I hope that this logic of reusing code makes sense to you. But let's now take it to the next level and really use some more functionalities of functions, because they can do a lot more than simply reusing a line of code like we did here. So usually when we write functions, we also pass data into a function. And additionally, a function can also return data as well, which means to give us data back that we can then use for something else in the program. So a function can not only reuse a piece of code like we did here, but it can also receive data and return data back. And so I like to think of functions as machines. So I think that's a great analogy. So for example, let's imagine a food processor. So we put food into the processor, then the processor does something to our food, which is the function body basically. And then in the end, the food processor returns the processed food, for example, a juice. And so that's exactly what we can do with functions as well. And actually, let's implement exactly this example. So again, we need to use the function keyword, and then we choose a function name. And just like with variable names, we should choose descriptive function names so that we know exactly what they do. So let's call this one a fruit processor. But in this function, we also specify something called parameters. And parameters are like variables that are specific only to this function. And they will get defined once we call the function. So let's give this fruit processor function two parameters, apples, and then a second one separated by a comma called oranges. And again, these two will get defined once the function is called, and they represent the input data of this function. Okay, and this will make even more sense when we then actually call this function. And let's start by logging these to the console. So apples and also oranges. And so what I'm doing here is to basically use these parameters here, so apples and oranges, just as if they were normal variables here inside this function. And now let's actually do something more interesting with these parameters. And so we want to kind of simulate that this fruit processor produces a juice out of the apples and oranges that we give it. And so let's just create a string which says that. So I'm going to create a variable called juice, and then a template literal, and I'm going to say juice with, and then I'm using actually the apples parameter here. So apples, and then apples, because this apples parameter will be a number once we call this. For example, if we set apples to 3, then the string will be juice with 3 apples. And again, this will really make sense once we call this function. So oranges and oranges again. Okay, so here we build a string using the input data that we get into the function. And now comes the really cool part, because now we can use the return keyword. And with this, we can return any value from the function. And so let's actually return the juice that we just produced. And so this value that we then return can be used anywhere later in our code. So basically, this juice will become the result of executing this function. And let's actually do that. So let's call or run or invoke this function now. So fruit processor, and now we're going to specify the actual values for the parameters apples and oranges. And so let's say, for example, 5 apples and 0 oranges. Okay, and so these now will be the inputs of the fruit processor function. So you can think of these parameters here like empty spaces that we still need to fill out when we are writing the function. And when we call the function then later in the code, here at this point, we then fill these blank spaces by passing in the real specific values, which will then get assigned to the parameters. In this example, apples will become 5 and oranges, which is the second parameter here, right, will become 0. And these actual values here of the parameters are called the arguments. All right, so let's now basically run this script. And so now we get 5 and 0. So this is coming from line 26, which is this line. So it's this logging to the console of the apples, which is 5, and oranges, which is 0. And apples are 5 because that's the value that we specified here. Okay, So we specified apples as 5, and so in this function, the apple parameter, or you can think of this parameter as a variable, is now 5. And oranges is of course 0. But now you might wonder, what about the juice that we just produced here? Where is it? Well, the juice was returned from this function. So basically that means that the result of running this function here is the juice that we just returned. Basically, once this function has been executed, this code here is then replaced by the result of the function. And in this case, that's going to be the juice string that we produced. So if we want to use that value that was returned, we need to store it in a variable. So let's do that. So let's call it apple juice. And then let's log that to the console. Reload it here. And now we get juice with 5 apples and 0 oranges. So let's recap again what happened here. So we called the fruit processor function here with 2 arguments, 5 and 0. And these arguments are the specific, so the actual values of the function's parameters, which are apples and oranges. And so when the function is running now, apples in here will be 5 and oranges will be 0. Then we use these values to build this juice string here, and then we return that value from the function. And what that means is that basically the result of calling this function here will be the juice value that was just returned. Okay? And then we need to save that value somewhere. We need to capture it. And we do that by basically saving it into this apple juice variable. And then we can simply log that value to the console. Of course, we could have also directly logged it to the console. So basically without capturing the value anywhere and simply logging it. So let me just copy this one here. And so if I run this now, we should see the same string twice. And yes, indeed, now the fruit processor function was executed twice, once here and once here. The only difference is that in this case here, we did not capture the value into any variable. We simply logged the result of running this function to the console directly. Okay, so just to show you the difference. Okay, and now thanks to the power of the function, we can reuse the function with different input values and then get a different output. So let's try that, and let's create a apple and orange juice. So apple, orange juice. And so this time we can call fruit processor, let's say with 2 apples and 4 oranges. So once again, we are defining specific values here, which are the arguments, which will get passed into the function here as these parameters. So essentially what we did here was to create a very generic function that works for any number of apples and oranges. So it's really like we're leaving apples and oranges as the blank spaces. And then when we call the function, we fill in these blank spaces using our arguments. So 2 and 4 in this example. And now we can also then log the result. So apple, orange, juice. And actually we can get rid of this console.log here because we don't really need it. All we want here is to produce this juice and then return the juice from the function. Okay, and so now we get 2 juices, one with 5 apples and 0 oranges, which is this first one, and then finally the juice with 2 apples and 4 oranges. And so that's the second one that we just produced. And of course, we could run this function as many times as we wanted. But we should call it at least once, because if we never call the function, then the code that's in the function will never be executed. And that makes sense, right? So without executing the function, it's kind of useless, because the code will never run. It will never be processed, because that only happens once we call the function like this, or like this here also. So as you see, this function here has no parameters. And so here, when we call the function, we do not specify any arguments. We could do that, so let's just pass 23, but since there are no parameters, it will not get used. And so specifying the argument here or not will not have any effect. You see that this function here also doesn't return anything, and that's not a problem at all. Not all functions need to return something, and not all functions need to accept parameters like the fruit processor that we have down here. So this is a very simple function here, and this is a more complete example showing you everything that we can do with functions. And this kind of function is actually way more usual than this simpler one here. So a function like this without parameters and without a return, we really only use when there's a block of code that we want to reuse over and over again. Once more, keep in mind that this function does not return anything. All it does is to log something to the console, but that has nothing to do with returning a value. This really only prints a message here to the developer console, but it doesn't return a value. So basically, this here does not produce a value because we don't return anything from the function. And that's why here we also don't save the result of the function to any variable, because it doesn't produce any result. Well, technically it does produce undefined, but that's not really relevant here. And so of course we don't capture that undefined value. Okay, great. And that's basically the fundamentals of functions. And I'm pretty sure that this was confusing for you if this was your first contact with functions. And actually, that's probably how it's supposed to be. So what I want you to do is to review this lecture very thoroughly and really understand how all of this works together. So how writing this generic function with the parameters works together with then calling the function with the specific values, and how the function then returns a value, and how in the end we then receive that value here and capture it into this variable. So that's what I want you to think about and to analyze. All right. So as a conclusion to this lecture, we can say that functions allow us to write more maintainable code, because with functions, we can create reusable chunks of code instead of having to manually write the same code over and over again. So that's the most important thing that you need to know about functions. And when you know that, you will know when you should actually use functions. And this is actually a very important principle for writing clean code that is used in programming all the time. And this principle is called don't repeat yourself, or dry. So we say that we should keep our code dry, which means that we should not repeat ourselves. And so functions are perfect for implementing dry code, because they are reusable code blocks that together make up our applications. And of course, we will use functions throughout the rest of the course because, as I said in the beginning, they are a fundamental building block of JavaScript programs. Oh, and by the way, you can now understand that console.log here is actually also just a function, but a built-in function that we do not have to write ourselves. But you see that we just call it like our own functions. So we call it using the parentheses here, and then we pass in a value. So apple orange juice. And the result of calling the function is simply this message then appearing in the developer console. And the same is true for the function that we used to convert a string to a number. So this is another built-in function that takes this 23 string in this case as a parameter. So we pass this argument into the function, and this function will then be executed and return the string as a number. And then we can save that like we did before. Okay, so this is going to work just the same. Oh, and of course we cannot see it, but we can still check it out by writing num. Okay, But now, anyway, I will leave you to really analyze how all of this logic here works that we just wrote. So do that now, and only once you fully understand how this example works, move on to the next video. Welcome back. So I hope that you studied the last lecture really well, so that you really understood what we did there with our food processor function. Now, in JavaScript, there are different ways of writing functions, and each type of function works in a slightly different way. But don't worry, they are still all very similar. So let's find out now. So the functions that I showed you in the last lecture are called function declarations, because we simply use the function keyword to declare a function, a bit like we declare a variable. So let's now write another function declaration, and this time a function to calculate an age based on a given birth year. So let's again use the function keyword, and we're going to call this one calc age1, and that's because we're going to have another one later. So as I said, we want the person's birth year as an input to this function. And what is an input? Well, it's just a parameter in this function. And a parameter, remember, is a bit like a local variable that's only available inside of this function. Then the function body with the curly braces, and now the code that we want to create here. So how do we calculate an age? Well, just like we did before, we take the current year, which once more, let's suppose it's 2037, and then minus the person's birth year. And then remember to take this value now out of the function, we return it using the return keyword. So we calculate the age first, and then we return that value. And actually we can simplify this and basically return all in one go. So there's actually no need to store this value here in a variable if all we do is then later return that value. So in fact, we can just take this value here, get rid of this, and then simply return the result of this expression here. So basically of this operation. Okay? So we're taking the birth year that we're going to receive and then use that to calculate the age. And so once again, this is a generic function which is then going to work for any birth year that we give it. So of course, let's now call or invoke or execute this function. And again, I can use all of these three words interchangeably. They all mean the same thing. So calc age1, and then remember to call the function, we use parentheses, and then we specify the actual value of the parameter, which is called the argument. Remember? So let's say 1991. Now some people use the words arguments and parameters as if they were the same, and actually that's not a big deal, but to be really precise, the parameter is, again, the kind of placeholder in the function, and the argument is then the actual value that we use to fill in that placeholder that is the parameter. Anyway, this will now create a value, right? And the value that this will create is the value that's returned from the calc age function. So basically this returned value. And so, once again, we need to capture or to save that value into a variable. So let's call this one age1. And just to make sure that it works, let's quickly check it out in the console. Okay. And indeed, we get 46, just like we did before. Okay. So that is a function declaration. But now let's create a function expression. So that's the other type of function that exists, and it looks like this. Instead of writing a function with the calc age name, we simply write function basically without a name, and then we still define the parameter. We still define the function body, which is going to be the same as this one, because we want another calc_h function here. So we write the function like this, and then what we have to do is to store all of this here into a variable. And that variable will then be the function. So let's call it calc_h2. So again, we did write the function in a very similar way, but we didn't give it a name here. So it's a function without a name, basically, which is also called an anonymous function. So all of this here is basically an expression, and remember that an expression produces a value. And so we use that value and store it into calc_h2. And this will then be the function. And I know that sounds very confusing, but it will make sense, trust me. Now, to call this function, we actually do it in the exact same way. So let's do h2 equals calc_h2, and let's use 1991 again. And then let's grab this console.log here and log both the ages. So h2 here. Let's also add some comments here. Function declaration and function expression. And so we should get twice the 46 value here. And yes, indeed. So the function expression works the exact same way as the function declaration. So we call it in the same way, we capture the returned value in the same way, and then of course the result is also the same because the function body is the same. But it's very important to know that we have these two types of functions in JavaScript, because in some places we will actually need to write them like this, as you will see as we go through the course. So again, this part here that I just highlighted, this function here is in fact an expression. And remember that expressions produce values. And so we just assign this whole value here then to this variable. And so this variable will then hold this function value basically. And one big implication of what I just said, so that this here is just a value, is that in fact in JavaScript, functions are actually just values. So just as a number or a string or a Boolean value. So a function is not a type, okay? It's not like a string or a number type, but it's also a value. And so if it's a value, we can store it in a variable. So just keep this in mind because it will become very important later when we really dig deep into functions. Now, besides these technical differences, you might be wondering, what is the big deal? So what's the big difference between function declarations and function expressions? Well, the main practical difference is that we can actually call function declarations before they are defined in the code. So let me show that to you. So here is the declaration, right? This is the function declaration. And as I just said, we can call them in the code before they are defined. So now we're calling it first and then defining it later. So let me show you that that still works. And indeed, we still get the same result. But if we attempt to do the same with the expression, then that should not work. So let's see. And so cannot access calc_h2 before initialization. Okay. And internally, this happens because of a process called hoisting, but more about that in a future section. Okay. For now, just keep in mind that you can call a function declaration before you define it, even though that might not be such a good idea in many cases. But you can do it if necessary. All right. Now, another question that you might have in your mind is, which of the two types of functions should I use when I write my own functions? And, well, the answer is that oftentimes it's really just a matter of personal preference. And so different developers prefer different formats. Personally, I prefer to use function expressions because this then forces me into a nice structure where I have to define all the functions first at the top of the code and only then I can call them. So this makes the code a little bit nicer and more structured. I also like to have everything stored in variables, so both values and functions. But again, that is just my own personal preference, and many other developers don't agree with this and prefer to use function declarations. So if you also prefer function declarations, that's fine, so just use declarations then. It's absolutely no problem. However, even if you prefer one over the other, you still need to know about both the function expressions and function declarations. So you cannot just pick one and then forget the other one, because both have their place in JavaScript. And so it's really important that you know how to use and how to distinguish both function declarations and expressions. So we learned about function declarations and expressions in the last video, but there is actually a third type of function that was added to JavaScript in ES6, and that's the arrow function. And an arrow function is simply a special form of function expression that is shorter and therefore faster to write. So let's actually get back this function expression from before here, so from the previous lecture, just so that we have a comparison, so like a reference point. And so now let's write the arrow function. And this is how we write an arrow function. So again, we want the birth year because we want to calculate the age again. And then we write an arrow. And that's the reason why this function is called arrow function. And then we simply write what we want to return. So in this case, that's 2037 minus the birth year. And that's it. Now to finish, we actually want to be able to use this function. So let's again store it in a variable, just like we did here with this function expression. So let's say const calc age3 this time, and then we set that variable to this function here. Okay? So as I said, this is a special form of a function expression because it still is a function expression actually. So it's a value, all of this, that we assign to this variable. So just like this function expression up here. But this one, as you see, is a lot easier and faster to write. The first reason for that is that we don't need the curly braces, like we have here to define a code block. And second is that the return actually happens implicitly. So this value here will automatically be returned without us having to explicitly write the return keyword. Okay? So this is excellent for simple one-liner functions. And you will see throughout the course that this is going to be extremely helpful in certain situations. And now to use this function, it of course works the exact same way as using all the other functions. So we call calc age3 just like we called the other calc age functions. Okay. And again, we save the returned value here to a variable. And then let's just check it out here. And so this one should be 46 again, just like we had in the previous lecture. And yeah, it works. So indeed, the value that we calculated was returned automatically without us having to write the return keyword. And you see that here we also didn't need any parentheses or anything like that. Just this here is the function. Okay? Now this is actually just the simplest form, which is when we only have exactly one parameter and only basically one line of code in which we want to return something. But it gets a little bit more complex when we add more parameters or more code. So let's now write another function, and we can get rid of this one since it was just a copy anyway. And so let's say that we want to calculate how many years a person has left until retirement. So let's call this function years until retirement. And then we set that equal to a function. And once again, let's pass in the birth year. then the arrow again, but now here we need some more code. Because to calculate the number of years until the retirement based on the birth year alone, we first need to calculate the age, and then from there we need to calculate the retirement age minus the current age. So we need more lines of code, and so we are back to actually needing the curly braces in order to define a code block like this. So let's do what we just said. So calculate the age based on the birth year. So 37 minus the birth year. And now let's calculate the years until retirement, basically. And so let's say that the retirement age is 65 years, as it is in many countries, here in Europe at least. So 65 and then minus the current age. And that will then give us how many years we have left. And now to return this retirement, we actually need to write the return keyword explicitly. So we can only omit the return here in case we have a one-liner function like here. But if we have more, then we need to do the return still. So let's now run this function. So years until retirement, and then again some year. And then, as always, we could capture the return value into a variable. But this time, let's actually log that value to the console directly. So console.log, and yeah, so let's try that. And so it's 19. So, and that makes sense because 65 minus 46, which is the age, is 19. Okay, so that's the scenario when we have one parameter here and then more than one line of code, basically. And remember, in that situation, we need the return statement here. But now, what if we had multiple parameters? Well, then we need to wrap the parameters here into parentheses. So in VS Code, we can just select a variable and then write parentheses, and then it will automatically wrap this variable into parentheses on both sides. So let's say that we want the birth year, but also the first name, so that we can like return something else, like a sentence. So let's comment out this part here, and instead let's return a string. And again, we're using a template string here to build that string. And basically I want to say like first name retires in X years. So let's use that placeholder here. So first name retires in, and then we use that value that we just calculated. So retirement, give it a save here, and now we need to call it. And so let's add the second argument here so that it will go to the second parameter. So the first one here is of course birth year, and so that corresponds to 1991. And now the second argument will go to the second parameter, which is the first name. So let's say Jonas, and let's just call it twice, so that it actually makes more sense that we even put this logic into its own function. So let's say that Bob was born in 1980, and so let's see how many years he has left. So Jonas retires in 19 years, Bob retires in 8 years. Great. And that's essentially how the arrow functions work. You just need to keep in mind the couple of different scenarios that there are regarding to the number of lines of code that you need and the number of parameters. So as you add more code and more parameters, it gets a little bit more complex, and we kind of lose the advantage of using an arrow function. So now you might ask the same question as before. What type of function should I use? Should I use arrow functions for everything since they are so easy to write? And well, the answer is no, but it's also complicated. That's because there is another fundamental difference between the arrow function and more traditional functions. So function declarations and function expressions. It's the fact that arrow functions do not get a so-called this keyword. And this, once more, is a topic for much later. So remember that learning is not at all a linear process. And so topics need to build up on one another in an incremental way. Otherwise, you would just get super overwhelmed and super stressed if I were to tell you everything at the same time. So for now, we will actually keep using mainly the normal functions, except for very simple one-liner functions. For example, like this one here. And that doesn't mean that arrow functions are not important. They absolutely are, and I love them and I use them all the time. Sometimes I don't write regular functions at all. But again, you cannot yet understand all the implications of using arrow functions. So for now, again, we will keep using probably the function expressions the most. Let's now take functions even one step further and calling one function from inside another function. And this is something that we do all the time in JavaScript, but I have seen many beginners struggle to understand this logic. And so I created a specific video just for this topic. And to illustrate functions calling other functions, let's go back to our initial example of a function being like a food processor. So let's move to the first functions lecture, which is this one, and simply copy this function. So remember that we had this function, which was like a fruit processor, which received a certain number of apples and a certain number of oranges, and then based on that, it basically produced and returned a juice to us. But now in this example, let's consider that the fruit processor can only make juice with smaller fruit pieces. And so before making the juice, the food processor now needs another machine that first cuts the fruits that we give it into multiple smaller pieces. So I hope that's not an example too silly, but I think it makes sense actually to understand the point that I'm trying to make. So let's actually start by writing that machine. So basically that function that cuts a fruit into multiple pieces. So let's say function cut fruit pieces, and then this function will receive a fruit. And all this function will do is to return the fruit cut in 4 pieces. So basically fruit multiplied by 4. So if we get 2 apples here, it will return 8 pieces to us. So simply the number 8. Okay, so that's our machine that cuts the fruit in pieces. And now here in the fruit processor itself, we receive the apples and oranges, and then we're going to use our newly created machine to cut the received apples and oranges into pieces. And so let's do that. So we start by calling cut fruit pieces in here with the number of apples that were received. And the result of calling this function, we will then capture into a variable called apple pieces. Apple pieces. Okay? And now let's do the same for the oranges that we receive. So orange pieces will be also cut fruit pieces, but we call it with the oranges. Okay? And so for the first time now, we called one function inside of another function. So if we now call fruit processor with 2 and 3, then this will call the fruit processor function, which then in turn will call the cut fruit pieces function. And actually twice, so once here and once here. And so let's now actually analyze how the data flows between these functions. So down here we are calling the fruit processor function with the arguments 2 and 3. And as we already know, this will then replace the apples parameter in the function with the number 2 and the oranges parameter in the function with the number 3. So that should be nothing new at this point, right? We are simply replacing the parameter placeholders with the actual values 2 and 3. And now let's analyze what's going to happen with this apple value. So apple right now holds the number 2. And that value 2 will then be used to call the cut pieces function, right? Now, as we call cut pieces, this 2 is actually the argument for the cut pieces function. And it will basically replace the fruit parameter, so the fruit placeholder. Okay, so now fruit here in this cut pieces function is also 2. And I hope that these arrows here make the data flow quite obvious. Then inside this function, of course, the fruit is then also 2, which will get multiplied by 4. And so the result here is going to be 8. And so the result of calling this cut pieces function with apples will be 8. And so that's the value that we then store into the apple pieces variable. And from there, we will then build this juice string that we have down here. Okay? So take a moment and analyze exactly how the data flows from one function to another, because I know that it can be a little bit confusing, especially calling the cut pieces function here without a tangible number. So we're calling cut pieces here not with an actual number that we wrote ourselves, like 2 or 3, but really with the argument that we received into fruit processor. So that can be a little bit confusing. So take a second to understand exactly what happens here. And what happened here with the apples variable will of course happen exactly the same with oranges. And so I'm not going to go into that part here, because that would be too confusing having all these arrows here on the slide. But of course you can analyze that for yourself and see exactly what is going to happen. But now let's move back to the code to see how this actually works out in practice. And so now we need to change this juice string here. So in the function that we just saw, it was already complete, but let's now write that out ourselves. So here we used to have apples, but now we want to use the apple pieces value. So apple pieces, piece of apples, and then here we want orange pieces, pieces of orange. So orange and apple here. Okay, so here we call the fruit processor function then, just as I explained in the slide. And then let's simply log the result to the console. There is no need in this case to store it into a variable. Okay, and so again, this works because the result of calling this function will become this string here that we return from the function. And so then console.log works with that string. So let's try that. And indeed, we get a juice with 8 pieces, which is 4 times 2 here, and then 12 pieces of orange, which is 3 times 4. And so that works just as expected. Great. So I think that was a really great example to illustrate this mechanics of one function calling the other. But now again, you might ask the following question. Why not simply multiply both of the input values by 4 and call it a day? So we could do that, of course. We can say apple pieces equals apples times 4, and orange pieces here is oranges times 4 as well. Well, but we did it this way for, well, multiple reasons. First, the point that I'm making here is that it's very common for one function to call another function. So just like we did here. And second, this is also a very good example to illustrate the don't repeat yourself principle that I mentioned earlier. So the dry principle. For example, imagine that suddenly the cutting machine would cut in 3 pieces and not in 4 pieces. Then if we didn't have the separate cut fruit pieces function, we would have to change the code in multiple places. And this is not a problem, of course, with 2 lines of code. But if we needed to cut like 10 fruits into pieces, then we would have to change that in all the places, and that would simply be annoying, and it could also be a source of bugs, so of coding mistakes. And so it's a lot better to put that functionality into its own function. So if the fruit was now only cut in 3 pieces, all we have to do is to change it here, and that's it. Then this changes to 6, which is 2 times 3, and this changes to 9, which is 3 times 3. Okay? So I hope that made sense to you and that you can start internalizing this kind of logic. With time and practice, you will exactly know when you should create your own functions and when to have multiple functions, one calling another. Great. Once more, congratulations for all the progress that you're making here. Working through these lectures about functions can be a lot of work, I know, and it can be sometimes a little bit confusing. So you're making great progress, and it's great to see that you're already at this point of the course. So again, functions is a very important topic, and so in the next video, we're going to take a couple of minutes to review the fundamental principles about functions that we just learned here. So stay tuned for that one, and I see you in a minute. To finish this part about functions, let's review everything important that we learned so far in order to make sure that you really understand functions before we move on to other topics. And let's start by bringing back and rewriting the function that we wrote before, which is the years until retirement function. So I think that was, it was here in the lecture about arrow functions. So let's copy this one and paste it here. And the first thing that we're going to do is to actually convert it to a more normal function expression. So how do we do that? Well, in this case, we simply get rid of the arrow here and then write the function keyword here. And so now this is just a regular function expression like we learned before. Next up, we could export this functionality here into another function. So like a calc_h function that we've been using before. So let's do that, because then we can do what we did in the last lecture, which was to call one function inside of the other function. So let's write another function expression here, calc_h equals a function, and then the birth year again. And what we return from this one is simply 2037 minus the birth year. So we already did that before, right? Now you might find it confusing that we have two different functions here with the same parameter names. So this one has birth year and this one has 2, but that's not a problem at all. So this birth year in this function is not at all related to this birth year in this function. They are two completely different parameters, so basically two different variables. We could even have a variable outside of any of the functions, which could also be called birth year. Okay, and we could do that now, but I don't want to confuse you even further. Okay, but what matters here is that this parameter is really like a local variable to each function. Anyway, let's now go ahead and delete this here, and instead calculate the age based on the function that we just wrote. And actually we just delete this part here. And so now the age will come from the function calc_h, and what we pass in here is the birth year. So again, it's confusing now with these same parameter names here, but let's quickly call this function just so I can quickly show you the data flow. So years until retirement with birth year 1991 and first name of Jonas. So 1991 will be the birth year here in this function. Then as a first step, this years until retirement function calls calc_h. And it calls calc_h with the argument of 1991. So this one here. And so then birth year in this function also becomes 1991. And so then here the operation will be 2037 minus 1991. And if you find it less confusing, we could change this year to something else. Let's just say year, and it would work the exact same way. Okay, so again, these variable names in these two different functions, they do not have anything to do with one another. All right, but let's actually put it back here because it's good to keep this in mind. Down here, let's actually go back to returning a number and not this string, which for now I will just comment out. So here we call this function, and once more, I'm not going to store it into a variable. So we will just log the result of this to the console. So this should be just like before, 19. Okay. But now I want to show you something, which is to call this function again. Let's say now with Mike, and let's say Mike was born in 1970. And so his years until retirement will be 2. So a negative number, which means that he already retired. So let's quickly account for that. So what we will do is to basically return this number if it is above 0, and if it is below 0, we are going to return something else, like -1 or something, or some special number. So instead of returning simply the retirement, let's take a decision here based on the retirement value. And so that's something that we learned in the last lecture. So let's use an if-else statement and say, if the retirement is greater than 0, so if there are more than 0 years left until retirement, then return this retirement value. Okay? So remember that in the if block, we can put any code that we want. And so that includes the return statement. And else, well, let's just return always -1. So -1 is kind of a standard number in programming. We could also like return like this. So a number that shows us clearly that this has no meaning. Let's just keep it at number 1, minus number 1, okay? And I'm returning actually numbers here and not a string as we had before, because that's usually what we do, especially when we actually receive a number as an input. So here in this function, we get birth year here as an input, and it's a number, and therefore it's a good practice to then also return a number. Okay, let's try this again. And I would even change it to something more drastic. So 1950. And let's see what we get now. Yeah, so it's -1 now. Great. Now, one thing that I didn't mention yet is that this return keyword here will actually immediately exit the function. So it will first return the value that we tell it to return. So in this case, the retirement value. And then after that, the function is done. So it exits immediately. And we also say that the function has returned. So let me actually demonstrate that to you. And what I will do is to take this string here. Now we can get rid of the rest. And I will put that after the return. So we will log to the console this string here that we just had. And then here, let's log simply the first name has already retired. And then we can put another emoji here, like this party emoji that I like. And yeah, what do you think will happen when we run this code now? And keep in mind that we have to return before the console.log in both cases. So in the if block here and also in the else block. So what do you think is going to happen with these console.logs? Well, let's see. And indeed, they are simply ignored. So they will not get executed because, as I said before, the return statement immediately exits or immediately returns the function. And so therefore, there's no chance that this code here is even reached. So if we want this one here to execute, we need to put it before the return. And in VS Code, I can simply hit Option or Alt up. Okay, and that will then move the line up. So we also have that here somewhere in this menu. So that's move line up and move line down. So just so you see which one is the shortcut. So I use that one all the time. I also use add cursor below all the time. And I also use add next occurrence. So that would be Command or Control D. So what this means is that we have, if we have this, for example, here selected, then we can already see all the other ones. But if we hit Command D, then it will actually select that. So you see, now we have these 4 selected. And so we now could replace all of them at the same time. For example, like this. Okay. But anyway, let's go back to what we were doing here. So I just moved the console.log before the return here. And so now there should be a chance that the console.log is actually executed before the value is returned. And so let's do the same here. So again, I'm hitting Option or Alt up. And so these 2 lines changed position. And now, yeah, now it works. So we get the string, and here we get Mike has already retired. Okay, so this was to show you some more things about functions that we had already learned, and also show you something new, which is the fact that the return statement here immediately exits the function. So we reviewed already some things here, but now it's time to really review everything that we learned so far about functions in these first couple of lectures. And here we have the 3 types of functions that we talked about. So we have first the function declaration, and one particularity about function declarations is that they can be used before they are declared in the code. Second, we have the function expressions, and they are essentially function values that are stored in a variable. And finally, we have arrow functions that are in fact also function expressions, but special ones. And these are great for quick one-line functions where we don't need to explicitly use the return keyword and no curly braces either. I also said that this one has no this keyword, but more about that in one of the future lectures. Now, what's important to note here is that these are 3 different ways of writing functions, but they all work in a similar way. So all of them can receive input data, they transform data, and then they can output data. It's all optional, but usually that's the things that functions do. And no matter which type of function we use, we can always do these 3 things. And now let's zoom in a little bit further and take a close look at the structure of a common function, let's say. And this one here is a function statement, but it works the exact same way for all other types of functions again. So first, usually a function needs a function name. So calc_age in this example. Then a function also has parameters. And these parameters are essentially placeholders that receive input values. So as I said before, these are a little bit like local variables of a function. So variables that are defined only inside of this very function. Now, as you also already know, we use functions to reuse pieces of code. And these pieces of code are inside the function body. So this is where the function's input data is usually processed and then returned. And speaking of the return, by the end of the function, we usually have a return statement, which we use to output a value from the function. And also, as I mentioned a little bit earlier, the return statement also immediately terminates the function's execution. We also say that the function returns. Okay, and now about calling the function. We do that using parentheses. So we write the name of the function like we did here with calc_age, and then with the parentheses, we call the function. Because without the parentheses, the function is really just a value. But then with the parentheses, we actually call the function. And we can also say that we run the function, or invoke the function, or execute the function, and all of these terms kind of mean the same thing. Now in this case, since the function actually has parameters, we then call the function with arguments. And these arguments are the actual values of the function parameters. So we use these to input the actual data into the function. And we can also imagine this as replacing the placeholders that are the parameters. Then, once the calc_age function has finally done its job, then all this expression will basically be replaced with the returned value. So in this case, the age that was replaced here. And that age value is what we then store into this age variable. So we use this variable to basically save the returned value that was outputted from the function. Okay? Now, just one other thing that I want to make clear is that this console.log that we have in the function, so in that first line there, has nothing to do with returning a value. This simply prints a message to the developer console, but it has nothing to do with returning. So actually, the console.log is actually just another function call inside the calcH function, because console.log is itself a function. And so the argument that we pass into the console.log function is what will get printed to the developer console. Okay, so just wanted to make sure that you really get this distinction between console.log and return. The reason why we always use console.log is because we want to see the results of our experiments in the developer console in the browser. Anyway, I think this pretty much sums up all there is to know, at least for now, about functions. So make sure that you got all of this down, and then you can move on right to the next video, where the first coding challenge of this section waits for you. And as you can probably guess, it's going to be about writing your own function for the very first time. So I hope to see you there soon. Welcome to the first coding challenge of this section. And as you can imagine, this one is going to be all about functions. And we're back to the two gymnastic teams from the previous section, the dolphins and the koalas. And now there is a new gymnastics discipline which works in a bit different way. So now in this new discipline, each team competes 3 times, and then the average of the 3 scores is calculated. So each team will get 1 average score. And then a team only wins if it has at least double the average score of the other team. And otherwise, no team wins. So sounds pretty simple, I hope. And let's take a look at your tasks now. So first, create an arrow function called calcAverage, which calculates the average of 3 scores. And actually, this calcAverage function should be able to calculate the average of any 3 values. So of course, the values don't have to be scores. Any random numbers will work just the same. So this is basically a generic function just to calculate the average of 3 values. Then use that function to calculate the average for both teams. And again, down here, you have the test data that you can use. Create a function called checkWinner, which takes the average score of each team as parameters. And these parameters should be called average dolphins here and average koalas. And then, based on these 2 average scores, the function will log the winner to the console together with the victory points. And that, of course, needs to happen according to the rule that I just explained before. So a team only wins if it has at least double the average score of the other team. And otherwise, no team wins. So you need to check for that condition in order to print which team wins. And in some cases, no team might win at all. So you need to account for that as well. So here in point 3, you write the checkWinner function. And then in number 4, you will use, so basically you will call the checkWinner function in order to determine the winner for both the test data 1 and test data 2. Okay? So I have some hints again, but if you want to try it on your own without the hints, then just pause the video right now. But if you need the hints, then, well, here they go. So this one is probably pretty obvious, which is to calculate the average of 3 values, add them all together, and divide by 3. But the second one here is a little bit more important and maybe more difficult for you to figure out on your own. So to check if number A is at least double number B, what you need to check is if A is greater or equal 2 times B. Okay? And so this is what you will use with the team's average scores. Okay, so it's important to keep this one in mind because of this rule that the team only wins when it has double the average score of the other team. All right. Now, please make really sure that you understood everything I showed you about functions before you attempt this challenge, because this one is not so straightforward. And so I don't want you to get frustrated. So again, please really make sure you understand functions and only then attempt to do this challenge. But if you feel that you're ready, then just pause the video now and good luck with this challenge. All right, so let me show you my solution to this challenge, which I hope, of course, you were able to do on your own. So I'm going to start with the calc average function as in number 1. And remember that this should be an arrow function, and it will receive 3 values so that it can calculate the average of these 3 numbers. And here I'm actually just going to call the 3 numbers A, B, and C, because again, this is supposed to be just a generic function which can calculate averages of any 3 numbers. It doesn't have to be any scores. And so ABC are just generic variable names. But of course, it's totally okay if you used more specific variable names. So adding all the 3 numbers together and then dividing by 3. So this one is nothing new. This was just to basically test your knowledge of the syntax of the arrow function. So what's important to notice here is that we need the parentheses here because we have multiple parameters, but then here we only really have this line of code. And so therefore, we don't need to even write the return. This value gets automatically returned from the function. And now let's just test it out before we move any further. So calc average, and then let's just use some random numbers because here we know that this is supposed to be 4, right? So we have 3, 4, 5, and so the middle one here is the average between these 3. And indeed, it is. And so we know that our function works. And so we can move on to point number 2, which is to use the function to calculate the average for both teams. So let's say score Dolphins is equal to calc average. And now we pass in the specific arguments for the 3 parameters A, B, and C. And so for test data 1, which is this, so let me actually write that here, test 1. So for the Dolphins, we pass in the values 44, 23, and 71. Then for the koalas, it works the same way. So score koalas equals calc average. And now we have 65, 54, and 49. So nice reusable function right here. And so having this function, we don't need to calculate it here manually every single time. So that's really great. So we can really appreciate the fact that, again, a function is really like a machine in some sense. So it doesn't care where the inputs come from and where they go. All it does is to calculate the average of 3 numbers, no matter if it's scores or heights of people or money or whatever it is. So this function really is kind of isolated from the rest of the code here. It's a standalone function that we can then use for our own purposes. And that might sound pretty obvious, but it's actually important that you really internalize this aspect of functions. Only then can you really start to see the potential for functions everywhere in your code. Anyway, with that being said, let's now log these values to the console, because I always like to see what I'm doing. So this part is of course not mandatory, but it's also nice to be able to know these scores so that we know if the logic that we're going to implement next is working correctly. So we see that in this case, the koalas have a score that is higher than the one of the dolphins, but it's not double. And so we already know that in this case, no team should be able to win. But let's now actually implement that functionality. So that's the function check winner. And so it takes the average dolphins and average koalas parameters. Okay. And then it logs the winner to the console. So let's do that. And once more, it's no problem if you did this differently. If you made it work, then it's great. So average dolphins and average koalas. And now all we need to do is to check whether the dolphins won or the koalas won, or if no one won, basically. So when do the dolphins win? Well, they win if they have double the points of the koalas, right? That's the condition. So again, a team only wins if it has at least double the average score of the other team. And so that's why I told you here in this hint that this is how we check for that. So A has double the amount of points of B if A is greater than 2 times B. So let's do that. So average dolphins greater or equal to 2 times the average koalas. And in this case, we log to the console dolphins win the trophy. So let's use an emoji here again, but you don't need, of course, to do that. So it's already here. And now it also told us to put the points. So, for example, 30 versus 13. So both points with the verses in between. So that's average dolphins versus average koalas. So you see that here we are also practicing all the other skills that we already acquired before, especially in the previous section, right? Okay, and now here we just need to do the opposite. So else if, and now if the koalas have at least, so that's basically what this one here means. So greater equal is basically at least. So if average koalas have at least double the points of the dolphins, then the koalas win. So let's just grab this one from here. Koalas, and here it's average koalas and then average dolphins. Average, yes. All right. And now in any other case, we say that no one wins. So I think that's also said in the rules. Yeah, that's number 5. I think I even forgot to tell you this one, but hopefully you read it. So you should ignore draws in this exercise this time. So if none of these is true, we simply say that no team wins. No team wins. Okay. And now all we need to do is to call this function here. So check winner, and we will do that with score dolphins and score koalas. Okay, so let's recap. We calculated the score of the dolphins up here and of the koalas as well. And now we call the check winner function here, okay? And we use as arguments the scores that we calculated before. And then score dolphins will become average dolphins here in this function, because that's the name of the parameter. And I see that I misspelled this. And so now I can use that Command D that I talked to you about before. So I can select all of them. So Command D, Command D, Command D, Command D. And now I can use all of these cursors here at the same time. So dolphins. You see, I inserted the P in all of the variable names everywhere. All right. And so now this parameter name here gets used for all these calculations. And again, originally this value comes basically from here, from calculating the average of these three scores. So this average gets stored here, then we use it here, and then it gets basically transferred to average dolphins and is then used everywhere in this function. Okay, so let's now test. And as we expected, no team wins, because this team here, even though it has more than the dolphins, it's not double. And so therefore they do not win. Now, of course, what is also important to mention here is that this check winner function here is also completely independent of these score values that we calculated earlier. So here we can simply call this function with completely different values. So the function doesn't care where these values come from. So where average dolphins and average koalas come from. It's a standalone function and it doesn't care at all where these values came from. We can just plug in some random numbers here and then call it. And let's use a smaller number here. Okay, so just so that the average dolphin here is actually more than double of the average koalas. So if we run this now, then we see that the dolphins win with 576 versus 111. And so that's exactly the numbers that we plugged in here. Okay, so once more, it's important to keep in mind that these functions are all independent from another. We just happen to call check winner here with these values that we calculated before. But it's not mandatory to do that. Any other values will work just as well. And so we proved that here. Anyway, now let's use test data 2. And actually what I'm going to do is to reassign these two scores here. So we calculate them first, then we call check winner, and then I'm going to recalculate them and call check winner again. So what I mean by saying that is that these need to be let variables so that we can reassign them. Remember that? Const values cannot be mutated. They cannot be changed. And so they need to be let. And then here, of course, we need to get rid of that let because we do not want to create new variables. We just want to overwrite. So we want to reassign the values that we had earlier. So this time the values are 85, 54, and 41. 85, 54, and 41, and I hope that's correct. And then for the koalas, we have 23, 34, and 27. So that's 23, 34, and 27. Let's log these actually also, and then simply call check winner again. And now with the new values of score dolphins and score koalas that we just reassigned. Okay, so let's see. And now the dolphins have an average score of 60 and the koalas of 28. And so now the dolphins win with 60 versus 28. So that's a close call. So if the koalas had 3 more points, then no one would win. But the dolphins managed to do it. Great. So I hope that this all made sense to you. And I know it is probably still a bit confusing at this point. And if you did some things differently, well then once more, that is completely okay. It just means you're developing your own coding style over time. For example, here with the average scores, of course, you could have created new variables down here for the test data too. So that's just one of many things that you could have done differently, which are perfectly fine. As long as your results are the same, you're good to go. So take some time and review this lecture. Remember that you can check out my final code also in the final folder in the GitHub repo. And then you're ready to move on to our next big topic in this section, which is going to be arrays. So I hope to see you there soon. Welcome back. Let's now talk about our first data structure, and that's going to be arrays. And let's say I wanted to store my friends' names in variables so that I could use them later in my program. And so with the knowledge that we have so far, this is how we would do it. So const friend1, let's say Michael, let's spell this correct, then friend2, Stephen, and then friend3, let's say Peter. Now, this isn't really fun to do, right? Because imagine that we actually wanted to represent 10 friends, and then we would have to create 10 variables. So that doesn't sound like fun. Instead, wouldn't it be great to essentially bundle all of these values together into some bigger container? Well, that's why we have data structures in JavaScript, and arrays are such a data structure. So an array is like a big container into which we can throw variables and then later reference them. And that's super important because programming is most of the time all about data. So we get data from somewhere, we store and process data, and then we give some data back. And that data, it has to go somewhere. So it has to be stored in some place. And for that, we use data structures just like arrays. So in case we have more than just a single value. The two most important data structures, at least in JavaScript, are arrays and objects. And so now let's learn all about arrays. So instead of doing this, let's create a variable which I'm going to call friends. And then we use the brackets to create a new array. And then in there, we can put different values separated by commas. And so let's now use the exact same friends. So Michael, comma, then Stephen, comma, and Peter. And make sure that these commas here are outside of the string. So that's an error I see people do. And so this needs to be one string. So you need to start and finish it, then the comma, and then another value, then another comma, and then another value. Okay, and now let's take a look at it in the console. Okay, and so this is what the array looks like in the console. So basically just as we wrote it in our code. And that is the absolute basics about arrays. So that's how we create one. At least that's the way that we use the most. But there's actually another way. So let me show that to you as well. So let's say we wanted an array of years. And so instead of the brackets, we could also write new array and then parentheses. And in there, we would then specify our values. Let's say 1991, 1984, 2008, and let's say 2020. So an array can hold as many values as we want, and also values of any type that we'd like. So it doesn't have to be strings like here. Of course, numbers work just the same. So here we used a different way of creating the array, which was using this array function. So you see that it's a function because we called it here, basically using these parentheses. And we also needed to use the new keyword, because otherwise it's not going to work. But anyway, it's way more usual to just use the brackets like I did up here, which is called the literal syntax. Great, so now we know how to create arrays, so basically how to put elements into an array, but of course we need to have a way to get them out. And for that we use the square bracket syntax again. So let's say that we want to log to the console the first element of this friends array. So that would be Michael. So console.log, and now we write friends. So that's the name of the array. And then we use the square brackets and then the number 0. That's because arrays are zero-based, which means that this first element is the element number 0, then this one is element number 1, number 2, and so on and so forth. And so if we want the element at position 0, so this first one, then we write friends, square brackets, 0. And that's it. And now let's say we wanted Peter here as well. So that would be element 0, 1, 2. And so let's just write 2 and check it out. And indeed, we get Michael and Peter. Cool. Now we can also get the actual number of elements that is in the array. So let's also log that one to the console. And this one works by saying friends dot length. Okay. And this dot length is something called a property, which we're going to talk about a little bit later in this section when we talk about objects. Anyway, what matters is that this is going to be the exact amount of elements that is in the array. And it's not zero-based. So it will not be 2, even though the last one here is element number 2. Instead, it really gives us the number of elements in the array. So we should expect this to log 3. And yeah, here we go. Now we can use this to automatically get the last element of any array. And that is useful so that we don't have to count how many elements are in the array. So let me show you how we could do that. Friends, and then remember to retrieve an element from the array, we need the square brackets. So just like this. And then to get the index of the last element in the array, all we need to do is friends.length minus 1. So friends.length minus 1. And that's because, again, friends.length is not zero-based. So this is 3, remember, but this last element is 2. And so we always need to subtract 1 from this number here. Okay? So what this also means is that inside of these brackets, we can put any expression. It doesn't just have to be a number, literally like we did here and here. So here we have this expression. And remember that an expression is something that produces a value. And so this one here is going to be calculated first. So it will compute friends.length, which is 3, minus 1 is 2, and then it will get friends at position 2. And that's also one of the reasons why it's important that you know what is an expression and what is a statement. Because once again, we could not put a statement in here. So inside of these square brackets, JavaScript expects an expression, not a statement. Anyway, we got the correct element from the array, which is the element number 2. And so that means that this automatic retrieval of the last element works just fine. All right. And moving on, there is more stuff that we can do. So this square brackets syntax that we used here is not only for retrieving elements from the array, but we can also change it to add elements to the array. So let's say that for some reason I'm no longer friends with Peter and that I want to replace him with some other friends. And so now we can change or mutate the array in the same way. So we can say friends at position number 2, and now I'm doing it manually here again. So we can say that this should be equal to something else. Let's say J. And if we now log this friends array to the console, then we should already see the new array. So friends, and let's see. And indeed, the element number 2, so this one here, is now replaced with J. Okay, so in the beginning, when we first logged the friends array to the console, it was still in this state. So it still had Peter. And that's why here in the beginning, we still see that original state. But then as we move on through the code, at some point here, we change that array. And so when we then log the array again, that change is of course reflected here in the output. But wait, Didn't I say in the last section that variables declared with const cannot be changed? And we did in fact declare the friends variable here with const, right? But I was still able to change one element of the array here from Peter to J, right? So isn't that a contradiction? Well, what I didn't tell you at the time is that only primitive values are immutable, but an array is not a primitive value. And so we can actually always change it, so we can mutate it. And it works this way because of the way that JavaScript stores things in memory. And once more, we will have a whole lecture just on that topic alone in a special section about how JavaScript works behind the scenes. So what you need to know for now is that we can actually mutate arrays even though they were declared with const. Now what we cannot do is to actually replace the entire array. So we cannot do this. We cannot say that the entire friends array should now be Bob and Alice. That would be illegal. So let's see. And now we get assignment to constant variable. And so that's why that we cannot do. But let's just keep it here anyway, so you get this as a reference. Next up, I want to show you that an array can actually hold values with different types all at the same time. So let's experiment with that. So let's create an array which holds all kinds of information about me. So let's say Jonas, so that would be the first name, then the last name, then the age, and here we can actually calculate the age from other values. And that works because in each position, JavaScript simply expects an expression. And so if we do this, then this is perfectly fine. Okay, so this will here produce a value, and so that's the value that will then be stored at position number 2 of the new array. And that also works for variables. So we could, for example, do first name equal Jonas, and then here instead of literally writing that, we could use this variable name. And so this would then be replaced with the actual string. So let's put some more data. And actually, we could even put other arrays inside of an array. So that's really cool. So let's put the friends array here in the Jonas array. And then with this, we have all the relevant data about Jonas in one handy data structure. And that's really convenient because then we don't have to create one variable for each of the data points. So let's, of course, inspect this now in the console so that you can see that all of these expressions here, basically, so this and this here and this, so all of them are going to be replaced with the values that they produce. And so, indeed, we now get Jonas, we have the calculated age, and here we have the array 3. And we can expand that by clicking on this small triangle here, and then we can see the actual array in here. We also have the length, so length is 5, and so that's where JavaScript gets this friends.length from. Jonas.length would of course also work, and it would be this 5 that we see here. Okay, so that's the one. Great, so these are the very fundamentals of arrays in JavaScript. And now just to finish this video, let's work on a very small array exercise so that we can see why arrays are actually so useful. And to do that, let's bring back our old calc_h function. So it's gotta be somewhere here. Yes, let's use this one. We've coded this so many times that I don't want to repeat it. So exercise. So calc_h. And now let's say that we have an array of birth years. And then we want to calculate the ages for some of them. So a new array And let's say 1990, 1967, 2002, 2010, and 2018. And now we will be able to use the calc_age function and then store the results of calculating the ages for some of these years into a new array. So let's see how, and let's see first how we could not do it, okay? So, for example, if we wanted to use the calc_age function for all of the elements in this array, we could not do this. This would be not illegal, I would say, but it's not going to work because this years is an array. And if we pass this years array as an argument to the calc_age function, it doesn't know what to do with it because this operation here expects a single value, and we cannot do a number minus an array. So let me actually show you what's going to happen if we run this. And well, that's not the error that I wanted to show you. So what we get is identifier years has already been declared. So this means that somewhere in the code we already have an array called years. And yeah, here it is. So let's change the name of this one to just y. So that one doesn't really matter anyway. But now let's see what happens. And well, not much did happen. So we actually need to inspect the result of this. So console.log and then the result of this. So let's see. And now we get the result, not a number. And so that's the result of attempting to subtract a whole array, which would be this years array, from a number. Okay, so let's actually do that here as well. Remember that we have access to all the variables that we declare in the script, also in the console. So that's the years array that we just declared. But years, for example, plus 10, does not work. At least not in a way that we expected it. So the plus operator, what it does here is to convert everything to a string, just like I showed you before. And so the string here is then basically this array as a string, and then it adds the 10 here. So that's not meaningful at all. And if we use it with minus 10, then it's even weirder. So we get not a number. So all of this is to say that we cannot really do operations with arrays. But we can still use the calc_age function on individual elements of the array, of course. So let's do that. And we will assume that I want to calculate the ages for the first, the second, and the last array element. So this one, and this one. So let's calculate this and then store the result into a variable called age1. Then we need to get rid of this parenthesis. And so as I said, I want to calculate the age for this first element. And so what we do is to take years at position 0. And so this here will then basically be replaced with 1990. And then calc_age is called with 1990, and the result is stored to age1. Now let's do this some more times. And say age2, age3. And here I'm using 1. So remember, I want this, and the last one. But I don't want to count the number of elements in the array. And so I use that trick that I just showed you in the beginning, which is to first compute the length of the array. So years.length, and then -1 to account for the fact that the index of the array is 0-based. And now we can quickly check out if this actually worked. So age1, age2, age3. And yeah, so we got 3 values here, which are these 3 ages. But we can take this even a little bit further. So since we started with an array, it's usually a good idea to also end up with a new array. So let's create an array, const ages, And now what should I put in here? Well, remember how I said up here that any position of the array simply needs to be an expression, so something that produces a value. And as we already know, this here produces a value as well, right? It is an expression. And so I can take this and simply put it as a position in this array. And so JavaScript will then go ahead, compute this value, and place it in the array. So basically, we can place function calls into an array just fine because they will produce a value. And now here we need to again do years dot length minus 1. And now finally logging it to the console, and then we're done. And indeed, we get the 3 same values that we had up here separately, now all nicely placed into this array. And this of course works because JavaScript will start by running these function calls, these 3 function calls here, and then place all the results in an array afterwards. Nice. And I think that should be enough for one video. I hope that you see how fun arrays can be and how useful they can be. And in the next lecture, we will make them even more useful by doing some operations with them. JavaScript has some built-in functions that we can basically apply directly on arrays. And these are called methods, and we can think of methods as array operations, basically. So let's now learn some useful array methods. And there are actually countless array methods in JavaScript. And in fact, we have a whole section dedicated to arrays alone. That's how important they are in JavaScript. But in this video, we're going to learn just some basic ones that you really need to know. And also so that you start to get used to the idea of using methods on arrays. Now let's start by bringing back the friends array from the last lecture. All right. And now let's start with a method called push. So the push method adds elements to the end of an array. And so let's say friends dot and then push and then the element that we want to add to the end of the array. So let's say j here. So push is essentially a function, and we can see that by these parentheses. So it's a function that we call, and we call that function really attached to the friends array itself. And that's what this dot here stands for. All right. So again, push is a method, which technically is a function, and we call that function directly on the friends array. So the push function is kind of attached to the friends array. And if you're wondering why that is, we will once more learn that a little bit later in the course. But there is a good reason why this works, and it's actually pretty fascinating stuff. So I hope that you're excited to keep continuing to explore this course until you'll really learn how all of this actually works. Now anyway, let's now check out the friends array in the console, because this is really all we need to do to add an element to the end of the array. And indeed, now we get the original array that we had before, plus the j element. And you see that the length is now also 4. Okay, so this actually changed, so it mutated the original array, but that's no problem at all, just like I explained to you in the previous lecture. Remember that? All right. Now, since push is a function here, it can also return something. So we already know that we can pass arguments into functions, and we did that here with j. Then the function can do some work, and in this case, the work that the push function does is to add the element to the array, and actually the push function does return a value. And the value that it returns is the length of the new array. So if we want to capture that data or that value, we can create a new variable for that. So let's call it new length. And let's then also log it to console. And indeed, it is 4. So most of the time we actually don't do this. So we just push an element and call it a day, because usually we don't immediately need the length of the new array. But in case we need it, we don't need to then calculate it separately. We can simply take the result of this function here, store it into a variable, and then use that. Great. Now, besides the push method, which adds elements to the end of the array, there's also a method to add elements to the beginning of the array. So that is the unshift method. So unshift. And so let's say we wanted to add John right to the beginning of this friends array. So again, let's check it out. And so now it should have 5 elements, and the first one should be John. And yeah, it is. And just like the push method, the unshift method also returns the length of the new array. But in this case, we are just not saving it because we don't really need it. Next up, we also have methods to remove elements from arrays. So these one here, add elements. So let me just write that here. Add elements. And then we have some to remove elements. And let's start with the pop method, which is basically the opposite of the push method. So this means that pop will remove the last element of the array. So let's write that here. And this time we don't need to pass in any argument. And that's because there's no information needed really to just take out the last element. So let's try that. Oh, we didn't log it again to the console. So let's just grab it from here. And now you see that J is actually gone. And if we did it twice, for example, which of course we can also do, then Peter should also be gone. And indeed, we removed J and Peter. Now again, this pop method also returns something, but this one doesn't return the length of the new array, but instead it returns the removed element. And so that can sometimes be useful. So let's call this one popped, okay? And so let's log that one to the console as well. So that is the popped element. And we could do the same for this first call. But as I said earlier, we don't always do this because it's not always that useful. But here I just want to show you that it actually works. And so the popped element should now be Peter. So this first one here is J, and then the last one becomes Peter. And so here in the second pop call, Peter is the one that's being removed. And so that's the element that's then going to be saved into popped. And yeah, here it is. Okay. And finally, let's also remove the first element from the array. And so that's friends that unshift. So let's copy this one again. Give it a save. And so now only Michael and Stephen should be left after all this manipulation, right? Oh, and actually that did not work. And that's because I did a mistake. So unshift is of course to add elements to the array. And so this one here is called shift and not unshift. So now it should work. Yeah. Once again, we didn't need any arguments. And once again, this method here will return the element that was removed. So if we need that, we can capture it. Next up, there is a very useful method that tells us in which position a certain element is in the array. So let's work with this small array that we have left. And what we want to log to the console now is friends.indexOf. And then we pass the element which we want to reference. So let's say we want Stephen. And so, as I said, this should return the index at which this element is located. So we know that Stephen is right now element number 1, right? So 0 and 1. And we actually can see that here in the console. So 0 is Michael, 1 is Stephen. And so this index of function call should return the value 1. Because again, that's the index of the element Stephen. And yeah, there we go. Now, if we try the same thing for an element that is not in there, let's say Bob, we will get -1. All right. And now finally, to finish this, this lecture, there is a very similar method to the index of, but which is a bit more modern and in my opinion also more useful. So this one is an ES6 method and it's called includes. So includes, instead of returning the index of the element, will simply return true if the element is in the array and false if it's not. So let's check that. So friends.includes, and now we can actually do the same as up here. So let me just copy that. And the difference here is again the includes method. So let's see what we get now. And as expected with Stephen, it is true because indeed we have one element here, Stephen, but Bob is false because, well, there is no element called Bob. And this method actually uses strict equality for this check. So let's say that we pushed some value here to this array. So friends.push, which remember will add a value to the end of the array. So if we added 23, and then if we checked for 23 the string, it would not work. So it would say false, right? And that's because it is testing with strict equality, which means that it does not do type coercion. And since 23 the string is different from 23 the number, it gives us false. But if I test it directly for the number, then it should be true. And yes, it is. So we added it here to the array, and so then of course the array includes it. That makes sense. And so we can use the includes method to write conditionals. So that's one of the very useful applications of this method. For example, just to test it out very quickly, let's say friends.includes Peter. And then, if so, we can log to the console. You have a friend called Peter. Okay? So we already know that this here returns a Boolean, and we also already know how the if statement works. And so only if this is true, so if the array does include a string with Peter, only then this code is executed. And so right now, of course, nothing happens. But if I ask for Stephen, then here let's say Stephen as well, then I get, you have a friend called Stephen. So that's probably the most used case of the includes method. All right, and that's all I had to show you for this lecture. And as I said in the beginning, there are many more useful methods for manipulating arrays. But for now, I just wanted to show you the most basic ones. And next up, there's yet another coding challenge waiting for you. All right, here goes coding challenge number 2, which is going to be all about arrays. And in this one, we're going to go back to the tip calculator that we built in the previous section. And we're still using the same rules as before. So we tip 15% of the bill value if it's between 50 and 300, and if the value is different, so outside of this range, the tip is 20%. And so here are your tasks. First, write a function called callTip, which takes any bill value as an input and returns the corresponding tip. And so that's going to be based on the rules that I just mentioned. And to do this, you can actually check out the code from the first tip calculator challenge that we did in the last section. So you can copy the code there, or if you want, you can also code this from scratch just to remember how to do it. And now in number 2, we're finally going to use arrays. So here we're going to create an array called builds, which will contain the test data that we have down here. So these are the 3 bill values for which we want to calculate the tips. And so that's what we do in point number 3. So here we create an array called tips, which will contain the tip value for each of the 3 builds. And this is where we're going to use the calc tip function that we created before. So that's the basic challenge. And if you want to take it one step further, you can even take the bonus question, so number 4 here, in which I ask you to create an array called total, which will have the total values. So that's the bill plus the tip. So I hope this one isn't too hard. Basically, it's similar to one of the examples actually that we did in one of the lectures about the arrays. And once again, I also have a hint to help you solving this one. But if you want to try it on your own without the hint, then pause the video now and good luck. But if you want the hint, well, then here it goes. So remember that an array needs a value in each position, but that value can actually be the returned value of a function. So as an array value, you can basically just call a function. All right. And again, that is similar to something that we did in one of the array lectures. So pause the video now, and I see you with my solution in a second. Okay, and I'm going to start by creating the calc tip function. And I'm going to start doing it with a function expression. So this one will receive a bill as an input, I believe. Yeah. So calc tip takes any bill as an input. So let's simply call it bill. And then what we want to return is the tip. And here I'm going to write the exact same code as we did in the other challenge. So there's no need to explain it all again. It would just be a waste of time. So if the bill value is between 50 and 300, so less or equal than 300, and here we're using the ternary operator, then return the bill value times 0.15, so that's 15%, and otherwise it should be 20%. Okay, so the result of this ternary operator here will be one of these values. So either bill times 0.15 or times 0.2. And so that's going to be the result of this operator. And so that's what this function will return. If you prefer the arrow function, we can also do that. So const calc tip equal bill. And now we can omit the return keyword and do it all in one nice line. So now you just have to choose which one you like better. And I will just, for the sake of readability, keep the first one there. Okay, but if you prefer the arrow function, you can just use this one. Great. So number 2 is to simply create a builds array with these 3 values. So builds 125, 555, and 44. So that was easy. And now we will create an array tips, which will contain the tip value for each bill. So let's do that. And now this is similar to what we did previously with calculating the ages. So we are going to create an array, and then each position will be the function call to calc tip. So we want to calc the tip with builds at position 0. Then at position 1, we want to calculate builds or we actually want to calculate tips based on builds on position 1 and then on position 2. And that's it. So let's log both the builds and the tips to the console here. And that gives us tips is not defined. So here it should be tips. So usually when I have an array, I like to give it a plural name, like here builds and here tips. So because it's multiple values. So now that should work. And yeah, so these were the 3 tips that were calculated. And of course, you could have created separate values or actually separate variables for each of these function calls, like tip1 equals calc tip with builds 0, something like this, and then tip2 and tip3, and then you could have created like an array with tip1, tip2, and tip3. Okay, so something like this. But my idea was to actually do it like this, because then we don't have to create all these extra variables. So that's a lot cleaner. Later on in the section, we will find an even better way of doing this. But with what we know at this point, this is the best that we can do. So we take the first bill, calculate the tip based on that, and put it in position number 0. Then we take builds at position number 1, calculate the tip, and put it in position 1 of this new array. And then we take builds at position number 2, calculate the tip, and put it at position 2 of the new array. And so then, yeah, we end up with this. Lastly, let's also complete the bonus question number 4 here. And all we have to do here is to create an array which will have the sum of the builds and the tips. So that's going to be totals. And now you might have tried to do something like this. So like builds plus tips. But as I told you in the previous lecture, this is simply not going to work. So we cannot do any operations on arrays like this. It doesn't work like that. So let me show you the result that we would get from doing this. And so basically, each of the arrays would be transformed to a string, and then the 2 strings would be concatenated. So that's completely useless. And so the only thing that we could do is to say that we want builds at position 0 plus the tips at position 0. And now we do this for all the 3 values. So at position 1 as well, and then at position 2. And so this fixes this error, because now in each position we do actually have a real value, because this is an actual value, and so with that we can then do calculations. So yeah, this is correct, looks correct, right? And yeah, so with that, all of the 4 points are solved. And so here we conclude this part about arrays. So after arrays, it's now time to learn about another data structure in JavaScript, which is objects. So up until this point, we have been using arrays as a data structure to basically store multiple related values in the same variable. So let's just quickly recap that. So Jonas array, and you don't need to write this code. Okay, I'm really just trying to recap here. So we had the first name, and you see that I'm writing this in multiple lines now, and that is perfectly acceptable. So sometimes that's easier to give us an overview of a data structure, as long as we remember the commas here after each of the elements, we're going to be fine. So then we have kind of this age calculation here. Then we had the job, and even an array of friends. So we have an array inside an array. So Michael, Peter, and Stephen. So again, this is basically a data structure which combines multiple values which all belong to this Jonas entity. Now we know intuitively that this first element here of the array should be called the first name. And this one is the last name. This one could be called age. This one could be called job. And this one could be called the friends. But in arrays, there's no way of giving these elements a name. And so we can't reference them by a name, but only by their order number in which they appear in the array. And so to solve that problem, we have another data structure in JavaScript, which is objects. So in objects, we actually define key value pairs. And so then we can give each of these values here a name. So let's see how. So again, we're defining a variable. And so I'm calling this one Jonas now. And then this is the actual object. So now instead of the square brackets that we use for arrays, we use the curly brackets or curly braces. So this is the second time we're seeing the curly braces. First, we saw them to define a code block, for example, in an if-else statement or if a switch statement, or even to define a function body. But this is different. Okay, so these curly braces here are to define a new object. And so let's now fill up this object with key value pairs. So the key is basically the variable name. So let's say first name, then a colon, and then the value. And the value can be of any type that we want here. Then to define another key value pair, we just separate them with commas, just like in the array. So last name, and then colon, remember, Schmettmann, then the age, and once more, we can put any expression here. So this will be calculated and then will be assigned to age. Then the job, which is teacher, and finally the friends. And let's just copy this array from here. Okay, and so with this we have now an object which contains 5 key value pairs. So again, these are the 5 keys, and then each key has a value. And so essentially with this, we were able to assign a name to each of these values that we had. So that's something that was impossible in arrays, but now it is possible. Now each of these keys is also called a property. So we say that this object here, so this object, which is called Jonas, has 5 properties. So property first name with the value of Jonas, property last name with the value of Schmettmann, and so on and so forth. Now, objects are probably the most fundamental concept in the whole JavaScript language. So there are many ways of creating objects. And simply writing an object in the code like this is probably the simplest way of creating an object. So here with the curly braces. So there are multiple ways of creating objects, but again, using the curly braces like this is the easiest one, and it's called the object literal syntax, because we are literally writing down the entire object content. So to recap, just like arrays, we use objects to essentially group together different variables that really belong together, such as the properties of Jonas that we've been working with. Now, the big difference between objects and arrays is that in objects, the order of these values does not matter at all when we want to retrieve them. And that's important to keep in mind. So in arrays, the order in which we specify the elements matters a lot, because that's how we access these elements, right? So we can only access array elements using their order number. This means that we should use arrays for more ordered data and objects for more unstructured data, and data that we actually want to name and then retrieve from the object based on that name. But how do we actually do that? So how do we get data from an object? And that's exactly what the next lecture is about. So see you there in a second. In this video, you're gonna learn how to retrieve data from objects and also how to change data in objects using both the dot and the bracket notation. So let's actually get the object here from the previous lecture. So that's Jonas object. And I noticed that we actually didn't even take a look at it in the console. So let's quickly log it. But we're actually not gonna see a big surprise. So all it shows us is really this same object that we just wrote in code. So it looks like this. So essentially just as it is here in the code. The only thing that's different is that the properties here are ordered alphabetically. And so that's what I mean when I said in the last lecture that the order of properties does not matter. And that's because we simply get the properties from the object using the property name itself. So that's actually the topic of this video. And so let me show you the two ways in which we do that. So the first way of getting a property from an object is by using the dot notation. And that is very straightforward. So let's log that to console. And so let's say that we want to get the last name. So all we have to do is to write Jonas dot last name. And that's it. You see, here is my last name coming straight from the Jonas object. So Jonas dot last name. And this dot here is actually an operator which will go to this object and then retrieve the property with the name that we specified here. Now we can do the exact same thing using the brackets notation. So let me show that as well. So Jonas, and then we use brackets in a similar way in which we retrieve data from an array. But here we need to specify a string with the property name, so with the key. So let's do my name again, or actually last name. And so these results should be exactly the same here. Now the big difference between these two here is that in the bracket notation here, we can actually put any expression that we'd like. So we don't have to explicitly write the string here, but instead we can compute it from some operation. Because remember that an operation is basically an expression. So something that produces a value. And so we can put that here inside the brackets. So let's actually try that. And imagine that we had a variable in which we store the repeating part in first name and last name. So we have name here in both. And so let's store just that inside of a variable. And you will see my point here in a second. This will all make sense, trust me. So name key, and then just name. So again, that's the repeating part in these two property names. And now we can use that variable to get both the first and the last name. So console.log, and then Jonas, brackets. And so now here we can insert the expression. So let's create a string first and concatenate it with name key. And here we could have built this string using a template literal, but in this case, it's not really necessary. So let's just copy this and then also last. So what will happen here is that as JavaScript sees this line of code, it will start by executing this plus operation, and so it will create the string first name. And then it will go to the Jonas object and retrieve that property. And the same for the last name here in the second line of code. And so that's how we get Jonas and Schmettmann. And doing something like this is more common than you might think. And so that's why it's important that we understand that in the square brackets, we could put any expression here. Okay? Now the same thing would not work with the dot operator or the dot notation. So we cannot write Jonas dot and then this here, for example. This would not work at all. So, an unexpected string. And so that's the reason why we need the brackets notation. In dot notation, we have to use the real final property name and not a computed property name. So, for example, this one. This one is a real property name as it appears in the object. And so that's why it works here in this case. So, in what situations should we use the dot notation, and when do we have to use the brackets notation? And I kind of already replied to that, but this is just to recap. So when we need to first compute the property name, like we did here with the first and last name, then of course we have to use the bracket notation. In any other case, just use the dot notation, which looks a lot cleaner and is also easier to use. Okay? And now to make the need for the bracket notation even more clear, let me show you another example, which I think is going to be really fun. So let's say that we don't know yet which property we want to show. And instead we get this information from some user interface. So for that we can use the prompt function, remember? So we can use prompt, and prompt is yet another built-in function that is built into JavaScript and that we can use in any script. So here we can write a string, and then this will create a pop-up window with an input field, remember? So here we can write, what do you want to know about Jonas? Choose between first name, last name, age, job, and friends. And remember that this function will then return a string, and this string we just need to store into some variable. So let's call this one interested in. All right. And to start, let's just log this interested in value to the console here, just so we see that it actually works. And so here is the pop-up. And so now we just write one of these options here. So let's say job. And indeed, now here we get job. And so what we want to do now is to basically display the job here in the console, because that's what the user chose. So how will we do that? Can we use the dot notation? So basically, can we do this? Jonas.interested in? Well, let's find out. But I hope that you can guess. And so we get undefined. And this is something new that I didn't explain yet. And so let me tell you now that undefined is what we get when we try to access a property on an object that does not exist. So Jonas does not have a property called interested in, right? And so therefore, the result of trying to access interested in on Jonas is undefined. Now, what we need to do here is, instead of the dot notation, use the brackets notation, because then we can put any expression here, which in this case will be interested in. And so JavaScript will now come here and replace interested in with the actual value of the variable, and then that's the one that will be looked up on the Jonas object. So let's try that again. And now, when I say job, we get the correct result. Great. And I hope that you did understand the big difference between using the dot notation and the bracket notation, and why the bracket notation gave us the correct result. So again, it's because basically this expression that we put here between these brackets will get evaluated. And then this one here is job. Now, of course, we can also pass in something else, so something that is not here. For example, let's try to access the location, and then again we get undefined. And once more, that is because there is not a property called location on the object. So let's actually handle that using some knowledge that we already have. So we know that undefined is a falsy value, right? And so we can use that to our advantage now and create some logic that will print a custom string whenever the user tries to access a property that doesn't exist. So let's do that. And we can say, if Jonas brackets interested in, then log that to the console. So basically this. And again, I'm using now the option and arrow down to move this line. And so if this value exists, then it is a truthy value because it is not undefined. And so any string that is not empty or any number that is not 0 will then trigger this code block here to be executed. Now, if one of these properties was actually empty or 0, we would then go to the else block, but let's not account for that here in this case. Let's say that doesn't happen. All right. So in case that the value does not exist, so for example with location, we then get undefined. And so in this case, Jonas interested in is undefined, which is false. And therefore we would go to the else block. And so let's say something like wrong request. And then we can repeat this sentence here. So let's try that again here. So location, and now we get wrong request. But if we try something that exists, then we get that result. Great. So I think this was a fun little experiment here. And yeah, I hope you liked that. And now that you know how to retrieve elements from an object, let's also learn how to use both the dot and the brackets notation to add new properties to the object. So that's pretty straightforward. So all we have to do is Jonas dot, and now let's actually use location and set it equal to something. So to some value. So I'm located in Portugal. And so that's how we use the dot notation. And then we can also, of course, use the brackets notation just the same. So let's say my Twitter handle here, which is @Jonas Schmettmann with just one N. And you should definitely check that out. And now just to see that it worked, let's log it to the console one final time. And okay, it's asking us for the field name again. But anyway, now we have the location and the Twitter here as well in the object. And of course, here we could put any expression just like before. So it works in the exact same way. All right. And that's how we use the brackets and the dot notation. Now, finally, I have one small challenge for you that you can just do right now here at the end of this video. And so what I want you to do is to write a sentence like this one that I'm going to show you now, but in a dynamic way. So let's just write challenge here. And so I want you to write, Jonas has 3 friends and his best friend is called Michael. So here we suppose that the first friend in the array, so in the friends array, is the best friend. Okay, and for the record, I do have more than 3 friends, but of course here we need to keep it all very simple. So again, I want you to write this sentence, but without hard coding any of these values. So what you need to get from the object is this value, and this value. And this is actually a bit hard, I would say. And so there's absolutely no need for you to nail this. But you can still try it, and maybe you can do some of the parts. One hint that I can give you is that you will need to use multiple dots to get the number of friends. Okay, so that's totally possible. And so take like 5 minutes to try this out now. So pause the video and I'll see you in a second. All right, and so this is how we would do this. So we want to log this to the console, of course. And so we're starting with the name. And this one is probably the most straightforward one. So that's just Jonas.first name. So that is where the name is stored. Then has, and then the number of friends. So the friends are stored in Jonas.friends. Now, do you remember how to get the number of elements in an array? It is by writing the array .length, right? And so let's do that. So Jonas.friends, and so this is our array, right? And so on this array, we can now ask for the length. And so basically you can see here that length is also a property that is available on all arrays. So it's a property that we don't define ourselves, but it's automatically available. But now that you know about the dot notation, you can also start to understand that the dot length is just a property that is available on all arrays. And so that's what we're doing here. So again, we have an array, which is this one. And on there, we can simply then request dot length. Okay, let's continue the sentence now. And his best friend is called, and now we need to simply get the first element from the array. And so that's again Jonas.friends. And now remember, we get the first element of an array using square brackets 0. And that's it. So once more, this here is simply an array. And so we learned that to take the first element, we just use square brackets with 0. So in a sense, on arrays, we also have the brackets notation. Okay, so let's just test this. And again, this annoying pop-up. But indeed, Jonas has 3, and we're just missing the friends here. So friends, and his best friend is called Michael. So just what I had written here as a template. Now in terms of operator precedence, let's quickly check out why it actually works this way. So with the dots here. Because remember, as I said, the dot operator here is really just that. It's just an operator. And the same goes for the brackets. So I will again Google MDN operator precedence. But the link to this table is also on the resources pages on my website. And the link to that one is right in the first text lecture of the course. But anyway, here we have the dot notation, which here is called member access. And then we have the brackets notation, which is here called computed member access. And so the computed is because, as I mentioned multiple times now, because we can compute the property names that we want to access. Now what matters here is that they both have a really high priority and both are left to right. And so that's why all of this works. So we have 2 dots here. So Jonas.friends.length, and they are executed left to right. And therefore, the first thing that JavaScript does is Jonas.friends. And so essentially, this will then be replaced with the array. And then on that array is where the dot length is then applied. And the same thing here. So first, Jonas.friends is done. And then this one is also left to right. And so from there, we take element number 0. Okay, so there's no magic involved here. There is rules for everything, and everything makes sense. And again, you don't need to memorize this here. With time, all of this will become second nature to you. Let's keep exploring objects. And this lecture will bring us to object methods. So we learned that objects, just like arrays, can hold different types of data. And they can hold even arrays, and in fact, they could even hold objects inside objects. But now we can take it even further. And for that, remember how I said that functions are really just another type of value. And if a function is just a value, then that means that we can create a key value pair in which the value is a function. And that then means that we can in fact add functions to objects. And so let's now see how. And once more, I will get back this object here, but we will change it up a little bit this time around. So here, let's simplify and just put the birth year. So just 1991. And I also want to add a Boolean here. Has driver's license. Just to show you that we can hold all kinds of different data types in one object. But now let's also add a function here as a key value pair. So to do that, all we have to do is to add another key here. And the function that we want to add is again the calc_age function. So that's one of the favorites, as you can see, but it is because it's a very simple calculation that we can do with the birth year. So to do that, let's simply add the name basically of the function here as a key. So as a property, so calc_age, and then the colon. And now here we simply specify the function as an expression. And that works because the expression produces the value. And so we can just do this. So function, and just like before, we pass in the birth year, and we return 2037 minus the birth year that was passed in. So this is pretty similar to simply writing this, right? So a regular function expression. So const calc_age like this. This is how we used to do it before. And so you see that this is pretty similar. The difference is just in the syntax, because now calc_age is not a regular variable like here, but it's a property of the Jonas object. And so therefore we use the colon here, but the rest here is exactly the same. And so that's why it was very important that you understood what a function expression actually is. Because here we need the function expression to create this method. And that's what this function is called. So any function that is attached to an object is called a method. So of course we could have not used a function declaration here. So something like this. So function calc_age, for example, that would not work. We would certainly get an error here. So unexpected token function, because this is a declaration. And so it doesn't work here. Here we need an expression. And so this will work indeed. Okay, does this make sense? So if you can think of functions as simply being values, then you can see that a method is actually also a property. It just happens to be a property that holds a function value. So here we have a string value, here we have an array value, here we have a Boolean value, and here we have a function value. All right. So I hope that's logical. And now, just like we can access any other property, we can also access the calc_age property or method. So Jonas.calc_age. And so calc_age is now the function value. And just like any other function, in order to call it, we use the parentheses. And now we can pass in the year here. And so that should then calculate our age. And let's just log this result to the console here, just to see if everything works. And it does indeed. Okay. And you could also have accessed this method using the bracket notation. Because again, it's just as if it was a normal property. And the brackets would actually be necessary here, so that this then here is the function, and then we call the function using the parentheses. So let's try that. And yeah, here this needs to be a string. So like I showed you in the last lecture, And now here we get 46 as well. Okay, so just like I showed you in the last video with the operator precedence table, the first thing that happens here is that jonas.calcH is computed. And so this here will become the function value. And then with the parentheses, we call that function value here and pass in 1991. And the same thing here. So here we access the property calcH using the brackets, and then this here will basically be replaced with the function, and then we call the function right here, just like before. All right. Now, you might have noticed that the birth year 1991 that we passed here as an argument to the method is actually already defined in the Jonas object itself up here, right? So we already have this information in the Jonas object. And so writing the same number here and here is not ideal, because we might make a mistake and pass in the wrong year. For example, right here. So Jonas's birth year is 91, but here we could, for some reason, accidentally do 92, and then it would be wrong. And even if we do not make any mistake, this is still not ideal, because we are not keeping the code dry. So we're violating the don't repeat yourself principle. So if we know the birth year of Jonas, it should only be written in one place, not in multiple places. Because if that might change, then we have to change it everywhere. That's always the philosophy that we need to keep in mind. So what if we could actually access this birth year property directly from the Jonas object instead of having to pass it in? Well, it turns out that we actually can. And that's because in every method, JavaScript gives us access to a special variable called this. And so what we can do now is in this calcH function, we can read the birth year directly from this object itself without having to pass it in as a parameter here into this function. All right, so let me copy this and comment this one out just so that we keep a record of what we did. But this here will be the new version. So now we no longer need this parameter, and we will read the birth year directly from the object. And for that, again, we will use the this keyword. So the this keyword, or the this variable, is basically equal to the object on which the method is called. Or in other words, it is equal to the object calling the method. So let's see who is calling the method. So down here is calcH, and the object that is calling the method is Jonas, because that's where the dot is. And let's forget about this one. I'll actually comment it out here. And so again, the object that is calling the calcH method here is Jonas. And so that means that inside this method, the this variable or the this keyword will point to Jonas. And so let me just write this.birthyear here, and then I can explain it even a little bit better. So here we don't need to pass the 1991 here, and I will run this now, and we still get the correct result. So great. And to make this even more clear here, let's also log this to the console. And indeed, this is the whole Jonas object. And so again, that's because the Jonas object is the one who is calling this method, so this function. See here, it's jonas.calcH. And so whatever appears before the dot is the one who is calling the method. And so therefore, in the method, this points to Jonas now. And if this points to Jonas, then this.birthyear is of course this value that we have right here. Great. So you see that the this keyword is something really, really useful. And we will learn even more about the this keyword in greater detail in a later section. For now, I just wanted to introduce you to this concept. And I know this can be a bit confusing, so really make sure to maybe pause the video and really analyze what's happening here. maybe you can even rewind a little bit and hear my explanation again. That might be useful too. Now, you might argue that maybe we don't even need this confusing this keyword. Why not just do Jonas.birthyear here instead? Well, because that would actually still violate the don't repeat yourself principle. It would work just the same here now, but then let's say that we need to change the name of the object. So we change it here to Jonas2, and then we call Jonas2 down here. And then the code will no longer automatically work. Because now Jonas is not defined, of course. And so we would have to keep that in mind and then come here and manually change this as well. While if we had the this keyword, then everything will keep working without us having to change it there. Because now this will simply point to Jonas2, because that is the object calling the method. And so therefore, it's always a good idea to reference the object itself and not hard-code the name of the object. So let's put it back to Jonas. And yeah, much better. So this works great already, and we're really going into some more advanced territory here. So I hope you're still following me and you're still making sense of everything. However, we can actually even take this a little bit further. But don't worry, it's not going to get a lot more confusing. Just a small variation of this. Because let's say that we need to access the age multiple times throughout our program. So that would be like calling this a couple of times. So let's say in 3 places of our application, we need to access the age. And so, of course, this will work. And indeed it does. And it always logs the Jonas object because we still have this here. So this makes it a bit easier to view. And so what happens here is that the function will get called a total of 4 times. And so this computation here will be done 4 times. And in this case, that's not a big deal, but it might be like a heavier computation that actually takes some more time. And so it would be a bad practice to do this multiple times. Instead, what we can do is to just calculate the age once, then store it in the object, and then when we need it at a later point, we can then just retrieve the age as a property from the object. So I hope you're following me here. So I will again copy this and comment it out so that we keep all the 3 versions that we did here. So what I was trying to say is that we can now use the this keyword also to store a new property. So we can say this.age is equal to this here. So we calculate the age, and then we create a new property on the current object. So in this case, on the Jonas object. And remember that we can use the dot notation like this to create new properties. So we did that in the previous lecture as well. Where was that? Yeah, right here. So here we created Jonas.location and set it to Portugal. And so here we are essentially creating Jonas.age and setting it to this age that we just calculated. And then we can simply return this age. And of course, we don't even need to return anything if we didn't want to. We could make this method only calculate the age, but not even return it. But I think it's a good practice to actually also return it. And so now here we can replace the function call with simply a request for the age property. And notice this trick that I did here again with the command D, right? So this gives me multiple cursors, and then I can do one operation in multiple places at the same time. So that's a really handy shortcut. So again, command D or control D, and in the menu bar, that means add next occurrence. So let's test this, and the result should be the same. And it is, but we only needed to calculate the age once. Then from here, we simply retrieve the property that we had already calculated before. And so this is the most efficient solution, let's say. All right, And now I actually have another small challenge for you that you can do just in this video. So I want you to write a method called getSummary, and this method should return a string which should kind of summarize the data about Jonas, or of course any other person data that you might have used. For example, let me again, actually we can get rid of this. So let me write challenge here again, and then do an example string. So I want you to write, for example, this. Jonas is a 46-year-old teacher. And we now could actually add all the data here to the string, but that would be too much work. And I'm a bit lazy now. So let's just also say if I have a driver's license or not. So Jonas is a 40-year-old teacher, and he has a driver's license. And it says that I have a driver's license because has driver's license is true. But if it was false, then here it should say, and he has no driver's license. So it's either A or no. So figure out how you can do that. And so I hope you managed to do it. It's a bit similar to what we did in the previous lecture, but this time I want you to actually write a method on your own. So give this a try, and I see you here in a second. Okay, so let's add getSummary. And remember that you need to have a comma between the properties. And so that's true also with methods. So here we need a comma, and then just a function. And it will then get all this data, of course, from the current object. So actually, let's first call this method. So, and we're doing it inside a console.log because, of course, we want to be able to see the summary string as a message in the console. So Jonas.getSummary. Okay, so which is the object calling the method? It is Jonas. And so therefore, the this keyword inside of getSummary will be Jonas. So I hope that this one is clear at this point. So let's now build a string here. And starting with the name, it is at this dot first name is a, and now the age. So this, and now what do we do here? Should we use the age property, or should we do calc age? Well, I would say that we should do calc age because we cannot assume that calc age was already called before. Okay, and if we don't call calc age before we call getSummary, then the age property would not exist. And so it's better to actually do calc age here. And so I think we did this before. So in a template string, we can easily do a function call. That's not a problem at all. So this.calcAge will call this other method, and this will then return the age. All right. And maybe it might be strange for you to call the function also on this, but well, the rule is just exactly the same. This is Jonas in this object. And so this is essentially the same as writing it here. All right. So this will become the age. And so year old, and now the job, Jonas.job. And he has, and now we need to decide between a and no. So let's do a ternary operator here. So we get this dot driver's license. And basically, if it's true, then we want the result of this operator to be a. And if not, we want it to be no. And then driver's license. Okay, Make sense? So again, here we want either A or no, depending on the state of the has driver's license property. So we get that property by calling this.has driver's license. And here we're using the ternary operator. And so if this first part is true, then the result of the operator will be A. And otherwise, the result will be no. And so that's what will then be put into this place of the sentence. Okay. And we already called the method down here, and we logged it to the console. And so I think this should work now. And it does. So Jonas is a 46-year-old teacher, and he has a driver's license. Now just to test, let's set it to false. And he has no driver's license. Beautiful. Okay. And yeah, that's all the code that I had to show you in this video. And now just to finish the lecture, which I know is already running quite long, but I want to basically build a bridge between this method and the array method lecture. So remember that we used methods on arrays previously. So we can quickly go there. So it was before this challenge. Yes, indeed. So for example, here we have friends.push. And so we have an array, and on there we call a method. So just like we did in this video. Now what this means is that arrays are actually also objects. They're just a special kind of object. And so they have functions, or in other words, they have methods that we can use to manipulate them, like push, pop, shift and unshift, and many more. All right. So in this lecture, we created our own methods on our own objects. But here we basically used built-in methods on arrays. And so once again, that means that arrays are actually also objects. That's why they can have methods as well. And we will dive deeper into why things work like this, but I wanted you to realize this early on in the course. This is quite a complex topic, and so there is really a very exciting journey still ahead of you. So I hope you're enjoying this journey so far. And now to test your knowledge, there is coding challenge number 3 coming up next. And here goes your next coding challenge. This time number 3, for you to review all the material about objects. And I hope that you're really doing all these coding challenges, because as I mentioned earlier, they are really, really important for your progress. And I designed them all very carefully to exactly match the progress of the course and place them in strategic points of the curriculum. So I cannot stress enough how important it is that you do these challenges, even if it's a bit difficult, but that's why they are called challenges. They are really to challenge you and to make you think, and if necessary, spend half an hour or 1 hour even to really try to figure out how the code works. Without coding on your own, it's impossible to learn programming, believe me. But anyway, let's now get to the challenge. And in this one, we're going back to Mark and John comparing their body mass indexes. And this time, we're going to use objects to implement these calculations. So here we have the formula again to calculate the BMI. And so your tasks are, first, for each of them, so for Mark and John, create an object with properties for their full name, their mass, and their height. So their full names are actually Mark Miller and John Smith. Then create a method called calcBMI on each object, which will then calculate the BMI based on the data that is on the object. So create the both method and add the exact same method to both objects. So write this method first in one of the objects and then copy the exact same method without changing it to the other object. And this method should store the BMI value to a property, and it should also return it from the method. So a little bit like the calcH method that we did in the previous lecture. Then log to the console who of the two has the higher BMI. And this string should look like this. So it should include the full name. And actually here it's not the full name, but do include the full name. That's why we have it. So John Smith BMI is higher than Mark Miller's. So not Killer's, but Mark Miller's. And then also include the actual BMI value here. And here is the test data, and I believe it's the same data as before. So good luck with this challenge. And again, it might be challenging, but please give it a try anyway. Okay, so I see you here in a minute, or maybe in half an hour, who knows. It doesn't matter how long you take. Okay, so let's get to work. So, number one is creating an object for each of them. So object Mark. So full name property Mark Miller. Then the mass, which is 78 kilograms, and then the height, which is 1.69 meters. So that's it for now. And now I'm just gonna copy this. As always, I'm a bit lazy, and that's just how programmers are, I guess. So John Smith, and he is 92 kilos and 195 meters tall. Okay, so that is point number one. And now we will create the calc BMI method. And then a function without any parameters, because we will take the data directly from the object, just like we did it with the calc age method previously. And remember that it says here that we should store the BMI value to a property and also return it from the method. So this means that we will do this dot BMI and then do the calculation here. And remember, from the formula, the BMI is calculated by this dot mass divided by this dot height squared. So exponentiation operator with 2. And then also return it. So this dot BMI. And just to see if this actually works, let's actually call this method. So mark dot calc BMI. And now I will quickly log to the console the property that we just created. So I could have logged this to the console directly, but I want to do it this way now, and it doesn't really matter. So with this, remember, we created a property called BMI. And so that is now, of course, accessible here. So mark.bmi, because remember that here in this method, this now points to Mark, because that is the object that is calling the method. And therefore, this .bmi will be on Mark. So mark.bmi equals mark.mass divided by mark.height. And so that's how we get this data into this method. All right, so that's essentially what we learned in the last lecture. And so here I'm doing the same. I'm first calculating this value, and then I'm doing mark.bmi, which was added here in this method call. Of course, without this method call, mark.bmi would not be available, because this method here doesn't call itself. We need to explicitly call it. Now console, missing the .log. How can that still happen after all these years? Okay, so here we get the BMI of 27, which seems about right. And now, as I said, we will simply go ahead and copy this method exactly the same to this John object, and it will work just the same. Believe me. So let me show that to you. So now we call John.calcBMI. And so now the object calling calcBMI is John. And so now in this method here, this will point to the John object. And so this time, John.BMI will be calculated using John's data of mass and height. Okay? Are you still following that? As always, you can pause the video, analyze the code on your own, or you can always rewind to hear the explanation again. I actually like to do that myself when I watch other online video courses. So I think that's a good tip, maybe. Anyway, so we just calculated the BMI of John here as well. And so now I'm logging both to the console. And so, yeah, this one also looks correct. And so this means that simply copying this method from one place to the other actually makes it work and adapt to the data of each object. Now, having the exact same code in both of these objects kind of violates the don't repeat yourself principle, right? And actually, there is a way in which we can avoid this. And of course, we will learn how at a later point in the course using something called object-oriented programming. But for now, we are still learning the basics and just want to make things work. And of course, have some fun along the way. So this was the hardest part, I believe at least. Now all we have to do is to write this string here. Let me actually copy the example so we have it as a reference down here. Otherwise, I'm going to get a bit lost. So, if mark.bmi is larger than john.bmi, then console.log. So let's get the full name now from the object. So mark.fullname BMI. And now we also need it here in these parentheses. So let's put it there. Mark.BMI is higher than, and now let me just copy it here. So, and again, I'm using Command D to select the next occurrence, and then let's just replace it with John. So Mark's BMI is higher than John's BMI. And now let's grab this again. Else, if John BMI is larger than Mark.BMI, then essentially say the opposite. So here it's going to be John. And again, Command D. And here it's going to be Mark. Okay. So 27 is higher than 24, and that 27 belongs to Mark. And so this seems to be about right, but it's not completely right. So, of course, here it should be lowercase. So BMI, and now I cannot use the Command D because then it will select this one as well. So I'm double clicking on this one, and I hope that you're finding these VS Code tips useful as well. So I'm clicking, or actually I'm double clicking on this one. Then I hold down the Command key, which in your case might be the Control key or maybe the Option key. So I know there are different configurations for this, and it might not even work for you. So please don't ask any question in that case. But for me, I just have to hit Command, and then I can double click on multiple words, and then all of them get selected. So now I have these 4 multiple cursors here again, and I can simply delete all of them and write the one that I'm interested in. So that's the lowercase BMI. And now we get the correct values. And also this conditional logic is correct as well. And so with this, we did actually solve the challenge. And with this, we also finished this introduction to JavaScript objects. And once again, I really want to congratulate you for the progress that you're making here. Great job and really well done. And I really mean it because I know how hard it is to stick to a course like this and to learn a completely new thing that is probably a bit confusing for you at this point still. Just keep in mind that that is absolutely no problem at all. And actually, in the next section, I believe, I have a video about how to learn, basically. So about learning how to code. And there's a lot of great tips that I'm sharing there. So once you reach that, make sure to watch it carefully. But now, anyway, I will leave you to review this lecture if you want, or to move on together with me to the next video, where we're now going to start talking about loops. When we talked about the if-else statement, I mentioned that it's a control structure, and also that there are more control structures, right? Well, one of the other control structures are loop. And so loops are our final big topic in this JavaScript fundamentals section. So loops are a fundamental aspect of every programming language because they basically allow us to automate repetitive tasks. So tasks that we have to perform over and over again. And here I like to use the analogy of a gym. So when you go to a gym, you might, for example, lift weights, right? And let's say that you do 10 repetitions of a certain weightlifting exercise. So we could represent that by doing something like this. So lifting weights repetition 1. And then some more emojis here. Okay, so repetition 1. And remember, we want 10 repetitions. So we would have to paste this code here 10 times. And I don't know even if this are 10 times or not. But anyway, you can start to guess that this is probably not a best practice. Just imagine that we had 30 repetitions instead of just 10. And then if we wanted to, for example, change some word here in this string, then we would have to change that in all of them. So this really violates the don't repeat yourself principle, right? Because we're basically repeating the same code here 10 times, and all we're changing is just this number. So instead of doing all this, we can now create a loop and then put one of these lines of code in there, and the loop will then run that code over and over again until we tell it to stop. And so let's implement a so-called for loop now. And that's a loop which has a counter. So let's do that. And we simply write for and open parentheses. So a little bit like the if statement, and this is a for statement. And so it looks similar. Now the loop statement has 3 parts. The first part is the initial value of a counter. And in the case of this current example, the counter is the value that will start here at number 1 and go all the way to number 10. So let's call this counter rep, which stands for repetition. And so here we literally create a variable called rep. And we start it at 1 because, well, that's our first repetition. Okay? And here we need to use a let variable because this counter will later be updated by the for loop. So that's the first part of the for statement. Then we use semicolon and go to the second part. And the second part is a logical condition that is evaluated before each iteration of the loop. So before each time that the code in the loop is executed. So let me just write it here first, and then this will make more sense. So our condition will be rep needs to stay below or equal 10. So again, this condition that we just described here will be evaluated before each iteration of the loop. Now, if the condition is true, then the next loop iteration will run. But as soon as this condition is false, then the loop stops. and so no more code will then be executed. So basically, the loop will keep running while this condition stays true. And this is really important to realize, and let me actually write that down here for you. So for loop keeps running while condition is true. So this is the kind of notes that I hope that you are taking throughout the course, but this one is really important, and so I wanted to write it down. Okay, and so now I hope it makes sense that we have this condition, because in each iteration of the loop, the rep counter will get increased. And so at a certain point, it will reach 10, and with 10, this condition is still true. So 10 is still less or equal than 10. But then after that, it will be 11. And so then repetition is no longer less or equal 11, and then the loop will stop. And at that point, we will have printed these 10 strings, basically. So let's continue writing this so that in the end, we actually make that work. So speaking of increasing the counter, that is actually the third part of the for statement. So another semicolon here. And now here we actually update the counter after each iteration. So that's necessary because right now the counter would just stay at 1 forever. And so this condition here would never be false. And so what we do here is to now increase the counter by 1 after each iteration. So we can say rep equal rep plus 1. But does this look familiar to you? So basically increasing the value by just 1. Remember that in the last section, we actually learned about a special operator which does just this, but in a much simpler way. So instead of writing rep equal rep plus 1, we can simply write rep plus plus. And so this will take the rep value and increase it by 1. All right. And now all we have to do is to write the code that we want to be repeated. And so let's copy this string here. Okay. And let's say 1, and then it will print this string 10 times. So let's start with that. And then afterwards, I will show you how we can actually update this number here. But for now, let's try this out. And actually, let's comment this code out so that it doesn't get in our way. So command / for that. And let's go. And indeed, we see that the string was printed 10 times. That's what this 10 here stands for. So the DevTools will not print the same string 10 times. It will simply put this 10 here. But what matters is that this logic here actually worked. So now let's actually use this counter variable that we created here to actually increase the number in the string that we're printing out. So how do you think we will do that? Well, it's actually simple. All we have to do is to replace this number here with the current value of the counter, because this variable that we defined here, so this rep variable, it's just a normal variable, and it's going to be available here inside of this code block. So let's transform this to a template string so that we can then insert that variable into the string. So we get rid of the hard-coded value, and now we basically dynamically build the string. And so here, all we need to do is to put the rep variable. And now we get exactly what we wrote here manually in the beginning, right? So that works. And so let's recap exactly what we did here. So we wanted to log our string here, so a string like this, 10 times. But of course, it could be any other repetitive operation. Again, we're just using console.log here so that we can see the result in the developer console. Anyway, in order to solve this problem of not having to repeat the same code over and over again, we used a for loop. And so we initialized the counter of the loop at 1. So right here, we created this new rep variable, and rep again stands for repetition, but it could be any other variable name, of course. And so we started at 1 because, well, we wanted to start at repetition number 1. But we could also start, of course, at repetition 5. So let's see how that looks like. And then, as you might have expected, the first repetition that's printed is the number 5. Okay, but let's put it back to 1 now. So after each iteration of the loop, we then increase this counter value by exactly 1. And this happens by the end of the iteration. So in the first iteration, this string here is logged to the console with the current repetition, which stands at 1. So this here will be replaced by a 1, and then afterwards the rep counter will be updated to 2. Then in the next iteration, this same string here is printed, but now with rep at number 2. Then rep is updated from 2 to 3, and so on and so forth. And these loops keep running while the rep variable is less or equal 10. So basically, while this condition here is true. And that's how we achieve exactly 10 repetitions. So what the loop does is to verify before each repetition if our condition here still holds true. And only if it does, it will keep running the loop. So it will execute the next iteration, and so it will execute this block of code here one more time. And of course, we could change it to something else. Let's put it at 30, and then we should get, indeed, 30 repetitions of the same string where only this counter here is changed. All right, and in a nutshell, that's how the for loop works in JavaScript. In the next few videos, we will see some more useful applications of the for loop and also talk about another type of loop that we have in JavaScript. Let's now explore some more features of the for loop and also create a somewhat more useful example. And one of the most used applications of for loops is to loop through arrays. So let's get back the array that we were using before. So where is that? So I mean the one where we talked about objects. Yeah, this one. So go to this lecture about Introduction to Objects and then grab this Jonas array. And maybe you didn't write it back then, but then you can just write it right now. Okay, and so now we can use a for loop to loop through this array. And let's say for now that we wanted to individually log every element of the array to the console. So very simple. All we want to do is to log these 5 elements here. So let's write a for loop. And as always, we start with the counter. So let, and now a traditional counter variable name has been I for a long time. And so let's use that here as well. So just I, and this time we need to start it at 0. And that's because the array is 0 based when it comes to reading elements out of the array. Remember? And this will make sense once we actually write the code of this loop. Let's now actually skip the condition for now. So we're going to deal with that a little bit later. And so now updating the counter is going to work exactly the same as before. So since we want to log all of the elements, we need to update the counter variable simply by 1. And so again, we use ++. Okay, and now let's write our loop here itself. So console.log. And remember, all we want to log to the console is each element of the array. And so without the loop, we would write that like this. So Jonas 0, right? And then let's do that outside. So we would do this, this, and then all the way to number 4, right? So let's comment this out, but this is helpful to see what kind of code we want to achieve. So again, we want to start at Jonas 0, which is the first element. Jonas 1 is this one, then 2, 3, and 4. And so that's the reason why we started the counter at 0, because that's the first element that we want to get. it's Jonas 0. And so here, instead of hard coding the 0, of course, we are going to use our counter variable. So, and that's I. And now the trickiest part here is the condition. And so that's why we left it for the end. But now we need to actually tackle it. So for how long do we want to keep this loop running? Well, it should run when I is 0, right? It should also run when it's 1, 2, 3, and 4, because 4 is the last element. But when it's 5, it should no longer run, right? And that's because Jonas at 5 does not exist. Let's just write that. Does not exist. And so that means that the I counter variable should always stay below 5. So let's write that here. So I should stay below 5. And so with this, as soon as the counter variable is updated to 5, then the next iteration of the loop will not run anymore. So let's try this. And here it's of course not Jonas, it's Jonas array. So let's actually change the name up here in the array itself. Try that again. And yeah, we get a log of each of the elements in the array. So all of the 5 of them. Great. But there's actually still one problem with this, which is that we hard-coded the length of the array here with 5. So let's now say that we add another element. Let's say just true. And so if we try this now, do you think that true will be logged here as well? Well, it will not, because of course we are still telling JavaScript that I should stay below 5. And so it will not print the array at position number 5, which does now exist. So now we do have Jonas at position 5, right? And so the solution to this is to not hard code the value here, but to compute this value. So basically to get it from JavaScript itself. And how can we get this number? Well, actually this 5 is simply the length of the array, right? Not of this one anymore, but of the original one. So this array has a length of 5. And so 5 is exactly the number that we put here. And so we can simply replace the hard-coded value with a dynamically calculated one. And that's Jonas.length. Remember? So let's try that. And indeed, it still works. And if I now go back to adding something else, like true, then Jonas.length will now be 6. And that of course happens automatically, and we don't have to manually change any code in that loop. So now indeed true also appears here in our log. Great. Let's now also log something else here. Let's say the type of the variable. So type of Jonas I. And I hope that this part here makes sense. So the fact that we're using the counter variable here to retrieve all the elements of the array. So now let's say, so string, string, number, string, object. So remember how I said that an array is in fact an object, and here we have the proof of that. And then finally the last one is of course a Boolean. Okay, so I hope that this logic here made sense. And so this is, in a nutshell, how we loop arrays using the for loop. Now, what we did here was only to read values from an array. But now let's also at the same time create a new array which will contain this type of each of the elements. So basically this. All right. So again, what I want to do now is to create a new array which will contain all the types for all these elements. And if that sounds a little bit useless, then just keep in mind that these are all just educational exercises. So I designed them to show you how these different features of the language work. So in the real world, we would probably not create an array with types of variables. But this is excellent to show you how to create a new array based on the values of one original array. So to do that, we start by creating a new empty array outside of the loop. And let's do that here after this one. So I will call this one types. And now I think this is something we didn't do before, which is to simply create an empty array. And all we have to do is to basically create an array with the usual syntax, but without any element inside of it. And so now we have to go here to the same loop, because this new array types will be based on the Jonas array. So it's going to have the same length. And so we can use the exact same loop that we used to read data from the Jonas loop, also to construct this new types array. So let's say types at position I should be equal to type of Jonas at position I. And remember that this works because we can essentially do this. So we could do it again without the loop and say types 0 is equals string. So this would work, right? And so of course it also works with the index number here dynamically. And so that's exactly what we're doing here in the exact same way as we read data from the Jonas array. Right? So in iteration 0, we will have type 0 equals type of Jonas 0. Then in the next iteration, we will have types 1 equals type of Jonas 1, and then 2, 3, 4, and 5. All right. So just to see if that works, let's then log to the console this newly created, or to be more accurate, this newly filled array. So let's see. And indeed, now we get this array, which has exactly the types that we can see here as well. So string, string, number, string, object, and Boolean. So these 6 that we also have here, which means that we achieved our goal here. Now, this is just one way of filling an array. And let me write that down here. Filling the types array. And here we do basically reading from Jonas array. But this is just one way of doing it. So let's comment out this one and do it in another way. And do you remember how to add elements to an array in another way? Well, we could use the push method, right? So that would be types dot push. And remember that push adds a new element to the end of the array. And so here we now need to pass in the element that we do want to add on to the array. And so that's again type of Jonas at position I. So of the current counter. And so if we try this now again, we should get the same. And it's important that we add the new element to the end of the array and not to the beginning. So we really need to use push here and not unshift. So I think that this way of doing it here is actually a little bit cleaner. But if you prefer this first way here, then of course you can just use that one as well. But what matters here is that we really understood the logic of how to construct all the different parts of this for loop in order to loop the array. So it starts with the counter being 0 because that's the first element of the array. And then this condition here, which specifies that the current index always needs to stay below the length of the array that we're looping through. And then in the loop itself, we always get the current element using the current counter, which is going to go from 0 to the length of the array minus 1, basically. All right. And to make sure we really get this, let's try another, maybe more practical example. So let's go back to having an array of birth years. So 1991, 2007, let's say, 1969, and 2020. And now what we want to do is to calculate the ages for all these 4 birth years here. And we want to store them in a new array. And that's a very common type of operation, which we actually already did before, but without using loops. So essentially that's what we did in the tip calculator challenge. So yeah, here. So here we had an array of 3 builds, and then we manually calculated the tip for each of them. So manually we specified the index 0, 1, and 2, and created a new array based on these values. But in the real world, we would have used a loop to do that. And so that's what we will do now. Okay, just with another, a bit more simple example. Years is the array which contains the birth years. And now let's create another, and again, empty array, which will then hold the ages. And so what we're going to do now is to loop through years and then fill up these ages array. So, for, and then once more, let's define the counter at 0 for the same reasons that we did it before. And it's not a problem that this counter variable here has exactly the same name. Then the condition is also going to be the same. And actually the whole loop always kind of looks the same when we loop over an array. So now here the difference is that it's of course years dot length. And then at the end we, as always, increase the counter by 1. And now what we need to do is to calculate the age of the current year. So that's going to be 2037. So as always, that's the year that we're currently in, let's say, and then minus the current birth year. So how do we get that? We say years at the current loop position. Okay, so that's nothing new, I hope, now at this point. Okay, so we have this calculation now, and now we want to add it to this new empty array. So we say we want to push it to that array. And so we use the push method to do that. So ages dot push. And so this is the value that we want to push into this empty array. And that's actually it. So let's check it out in the console. And here we go. So just to confirm, 2037 minus 1991 is of course 46. And let's just do it with 27 as well, 2007, I mean. And so that's 30, which is this one. And so this array result is correct indeed. So what we essentially did is this. We cannot do operations between simple values and an array. So that I showed you earlier, right? We cannot do 2037 minus the years array. That will just give us not a number. And so here in this loop, we basically did it individually. So we did the calculation one by one. In each iteration of the loop, we calculated 2037 minus this year and then added it to the first position in the ages array. Then we did 2037 minus this and put it at the end of the ages array again. And then the same for this one and for 2020. Great. So that is a very, very useful and important application of the for loop. And now to finish, let's learn about two important statements for loops. And that's the continue and the break statement. Let me just write that here. Continue and break. And let's start with continue. So continue is to exit the current iteration of the loop and continue to the next one. On the other hand, break is used to completely terminate the whole loop. So let's see two quick examples for that. And let's go back to actually this first loop that we had here, where we looped this Jonas array. So I will just copy this because we already learned how to loop through the array. And now I'm just interested in showing you how continue and break work. So let me delete this and this as well. And now let's say that for some reason, we only wanted to print elements to the array that are strings. And the continue statement is perfect for this. Because again, with continue, we can exit the current iteration of the loop. So what we can do here is to say, if the type of the current element, so of Jonas I, is not a string, then continue. And so that's how we write the continue statement. It's really just this continue keyword. So again, what we want to do here is to only log strings to the console, which means that everything else should basically be skipped. And that's what we do here. So we say if the type of the current element, so that's this one here, so if the type of the current element is not a string, then continue, which again means that the current iteration of the loop is exited and then the next one starts immediately. So let's just write some other note here to the console just so we know what we're doing here, like only strings, because otherwise the output here is going to start to look a little bit confusing. But anyway, let's test this now. And indeed, we only get strings now. So these three are strings and all the other ones are not strings. So this number, this array, and this boolean, so they will now not get printed because we basically skipped them. For example, that age number, which is 46 here, so the third element, does have the type number here, right? So it's not a string, and so this here will be true because, of course, number is different than string. And so this is true, and so this code here will run. And what continue will do is that it will immediately exit the current iteration. And so this line of code here will not be executed in the current iteration. It will not even be reached. Okay? And now finally, let me just show you how break works. And remember that what break does is to completely terminate the whole loop. So not just the current iteration. So what we want to do now is to log no other elements after we found a number. So essentially, after a number is found, which will be this 46 here, nothing else should be printed. So let's do that. And I will again copy all of this. And so let's say here, break with number. So let's translate the logic that we just said into the code. So as soon as a number is found, we want to break the loop. So our if condition here should be type of Jonas I, so the current element, if it's equal to a number, so now that's number, then break. Now, okay, let's see the result here. And indeed, that's exactly what we wanted. So after the first number is found, which is this 46 here, nothing else is printed. So in this iteration, where the number is found, not even this line of code is printed anymore, and then the loop is terminated completely. All right, now this might not sound very practical, but believe me, there are some important use cases for continue and break. It's just hard to create some small and isolated code examples to show you just how useful they can be. But anyway, I wanted to let you know that continue and break exist. But the most important takeaway from this lecture is definitely to understand how we can loop through arrays using this kind of logic here. Okay, so this one here is really important that you understand this snippet of code. In this lecture, we're going to do two interesting things. First, we will loop over an array backwards, and then second, we will also create a loop inside another loop. So let's have some more fun with arrays now. And so let's get back our array again here. So the Jonas array, and let's forget about this element here. And so now, as I said in the beginning of this video, let's now loop over this array backwards. So the first element that we want to print is this one, then this, and finally Jonas. So essentially, in the last lecture, we looped from the beginning. So we started with index 0, then 1, all the way to 4, right? But now we want to start at 4. Then we want to go to 3 and all the way to 0, which is going to be the last index. So this one is 4 and this one is 0. And so now we need to create the for loop according to this new information. So basically according to this new methodology. So let's start again with the counter, and we'll name it I again. But now what should be the initial value of the counter? And we already replied to that question kind of. So it should be 4. But should we just write the 4 here? No, we shouldn't, right? Because we already learned that hard-coded values like this are not a good idea. So what is 4? Well, 4 is basically just the length of the array, which is 5 minus 1. So that's exactly what we will write here. Jonas.length minus 1. Then the condition, and when do we want the loop to stop? Well, it should stop after the 0. And so the condition we need to write, remember, is telling JavaScript in which condition the loop should keep running. And so basically the loop should keep running as long as the counter is still above 0. So I should be greater or equal, actually, 0. So let's quickly simulate that. So at number 4, which is in the beginning, I is greater or equal 0, right? So this condition will be true. And so the next iteration will run. Then we need to decrease the index or the counter. And so let's actually do that as well. And so instead of using I++, which we used before to increment the value, we use minus minus to decrement or to decrease the value by 1. And so now we move from 4 to 3. And 3, of course, still is greater or equal 0. Then all the way to 0. And so 0 is still greater or equal 0. Then the counter gets updated again, and it will be updated to minus 1. And now minus 1 is not greater or equal 0. So this is false, and so the loop will stop. Okay, so I hope that this was not hard. Really, all we have to do is to think when we create these 3 parts here of the for loop. And I hope that you could follow my train of thought here. Now anyway, the rest, of course, is going to work just exactly the same. So we're getting, again, the current element. So let's check that very quickly. And yes, great job, it works. And just to really show it, let's also log the counter variable itself. So first the I, so the counter, and then the array value. And so indeed, this works just as we intended. We start with number 4, just as we have it here. And then we move to 3, 2, 1, 0. And if we now edit one element, then for sure, this is going to work just the same. Because now Jonas' length is 6 and minus 1 is 5. And so it will start here at true. And indeed, it does. All right. Now you will probably not be doing this all the time in your own code, but I thought that this was a nice exercise so we could again think about how to define the counter, the condition, and the counter update. Okay, so that was the first part of this lecture. And now I want to show you how we can create a loop inside of a loop. So does that sound crazy? Well, it's not so crazy. And it's not so difficult either. And to do this, let's go back to our gym example from the first loop lecture. So there we had 10 repetitions for a certain weightlifting exercise. Remember? But now let's say that we have 3 different exercises and we want to repeat each of them 5 times. So that means a total of 15 repetitions, 5 for each of the 3 exercises. So to log all these exercises, we will need a loop inside a loop. So let's roll up our sleeves and get to work here. And we're going to start with the 3 exercises. So let's create a counter, and I will actually call it exercise. So exercise, and we start at 1 now this time again, because we simply want to log exercise 1, 2, and 3. So our condition here is that the exercise should be less or equal 3. And actually, this would be exactly the same as writing exercise below 4. So you can do whatever you prefer most. And I think I will actually stick with this one this time. And then we need to increase the exercise after each iteration as always. So now let's log to the console something like this. Starting exercise, and actually here we want to include the exercise number. So let's instead create a template literal. And so here we use that counter variable. So let's just check this one. So we have 3 exercises, but we don't have any repetitions yet in there. And so now, again, we need to create a loop inside a loop, so that in each exercise, we can have the 5 repetitions that we want. And the repetitions themselves are a loop, right? And so that's why we now need that loop inside of this loop. So let's do that. And this is going to be basically the same as we did earlier. So let's again call it rep, start at 1, and then the condition. So remember how I said that we want 5 repetitions this time. And so let's say we want to stay below 6. So again, that would be exactly the same as writing less or equal 5. But let's keep it a bit different this time and say below 6. And then rep plus plus. And now lifting weights repetition. And again, I forgot to make this a template literal. So yes, this should work much better. And now this cute emoji here again. Oh, where is it? And let's test this now. So what do you expect to see? Think about that before you load your own result, or before I load here the result. So, is this what you expected? Let's even increase this here a little bit. And now we see the full picture. All right, so we start exercise number 1, which is what we have here. And then inside of this iteration of exercise 1, a new loop is created and executed. And so that's what then creates this lifting weights repetition from 1 to 5. All right. Then this loop here is finished, right? So it run all the 5 times, and then this first iteration is finished. And so the exercise loop, so this outer loop here, goes to its second iteration. And so we are at exercise number 2. And then this whole loop here will run again from 1 to 5. So that's these 5 here. And then that loop again finishes. And then the exercise iteration finishes. And we go to iteration number 3. So exercise is now number 3. And then the whole repetition loop, so this inner loop here, will run 5 times again. And with that, we end up with a total of basically 15 repetitions, just as I said in the beginning. So 3 times 5. Okay? And we could even include the number of the current exercise in this string that we're printing here. So let's do that as well. Exercise, and then exercise. So this is the variable that we get from the outer loop. And so this variable here is of course available inside this whole loop. And that does include all the inner code, even this inner loop. And so that's why we can access this variable here as well. And so now we should see exercise 1 printed for these 5, then exercise 2 printed for these 5, and exercise 3 for the last ones. And yeah, beautiful. All right. I think this was a very fun exercise. And again, even though you might not use this all the time in the real world, I still think that this was a pretty cool example to show you some more power of loops. And now to wrap up this section, all there is left to learn is another type of loop, which is the while loop. All right, so we learned all about the for loop and even created a loop inside a loop. But there is another type of loop in JavaScript, and that's the while loop. So let's explore that one now. And to understand how the while loop works and the difference between the for and the while loop, let's actually go back to our first for loop lecture and get back the code of this weightlifting exercise. So just copy this and we will keep it for comparison basically. So let's put it back to 10 here as well. And so let's now do the same thing with a while loop. So implementing the same with a while loop, we still need the same components. So we still need a counter so that we can then actually print the current value to the console. We still need a condition so that we know when to stop, and we still need to increase the counter somehow. Now in a while loop, it works a bit differently because for the while loop, we can only specify a condition. So while, and then just the condition is the only thing that we can specify here. So that's going to be exactly the same as this one. So we want to keep the loop running while repetitions is less or equal 10. And that's actually why this loop is called while. So again, it's called the while loop because it will run while this condition is true. All right, but now we need to kind of manually, so more explicitly define the other two components of the for loop. So the repetitions and the increasing of the counter. And so we need to do that basically outside. So we start at the beginning with rep equal 1. Then we have the condition. Then let's put the code that we want to execute. And then at the end of the iteration, we will then increase the counter. And so let's just do that. So at the end of the iteration is basically the end of this code block. And so let's do that there. And that's it. And so now we should get the exact same result twice, once coming from this for loop and once coming from this while loop. And yeah, so 1 to 10, and then again 1 to 10 coming from the while loop. Just write that here, just to make 100% sure. Yeah, and indeed, the second set here is coming from the while loop. So this all means that the while loop is more versatile than the for loop, which means that it can be used in a larger variety of situations. And that's because it does not really need a counter. So we put the counter here because we need it for this specific use case. But all the while loop really needs is the condition, which needs to stay true for it to keep running. And that condition can be any condition. It doesn't have to be related to any counter at all. And sometimes that's exactly what we need to solve a certain problem. So a problem without any counter. So without a number that is increasing. And so let's create such an example here. So I will start by taking off this for loop. We no longer need that one. And now we will do a simple example that does not depend on a counter, but instead it will depend on a random variable, okay? So what we're going to do is to basically roll a dice and then keep rolling the dice until we roll a 6. And then when we roll a 6, we stop. So essentially, we will want to keep running the loop while the rolled dice is different from 6. And so in this case, we do actually not know beforehand how many times the loop should run. And so we don't need a counter variable. And that's exactly the use case of a while loop. So let's start by creating that random number. And so the roll of a dice is a number between 1 and 6. The way that we implement this does not matter at this point. Okay, we will learn more about random numbers at a later point. And so for now, basically just type what I am writing here. So we're using math.random, and this will create a number between 0 and 1. Then we multiply that by 6, but this is going to be a decimal number. Let me just show that to you quickly, because I think this is still interesting for you. So you see that it's a decimal number, and so now we need to get rid of this decimal part. And so that we do using math.trunc. And so this will give us a number between 0 and 5, and then we add 1 and get 1 to 6. So again, don't worry about the implementation of this at this point. We will do this again later. But what matters here is that as we reload the page, we get a random number here that is different every time. And so it will be different for you, of course. So different from what you see in the video as you keep reloading your own page. Okay, and so now let's do what I explained earlier. So again, we want to keep running the loop until we roll a 6. So until this dice variable here holds the value of 6. And so the condition of the loop is now going to be dice different from 6. And as soon as the value is 6, it will stop. And let's log the value to the console here. So you rolled a and then dice. And so let's get rid of this one here. And now let's log it to the console. But keep in mind that actually right now we are only creating one dice value. So at this point the loop doesn't make a lot of sense. And so actually let's keep working on this before we test it. So again, we are only creating one random number between 1 and 6 here, right? And if that's different than 6, this loop here will run. But right now, the loop would then run forever, which I'm not going to show you here now because that would crash the browser. So this would be called an infinite loop, and we don't want that. So what we will do is to keep creating new dice values. And so we are going to reassign this value at the end of each iteration. And so now we're ready to test the result here. Whoa, you see we got a lot of dice rolls here. Let me actually also comment out just this console.log here. And so of course your result will be different from mine because we are using different random numbers. But anyway, let's analyze what happened here. So we start with some random dice number, and then here we check if that dice is different from 6. And apparently it was different. And so then we entered the loop, which then logged you rolled a 2. So my random number was first a 2. Then in the next line, we created a new random number, and then the loop ran again. So again, this condition was tested. So is the dice different from 6? And apparently it was. And so we entered the loop again. And so it printed you rolled a 1. And then the next dice was a 5. And then the next one was a 4. But then apparently the next dice that was rolled here was a 6. So at the end of this iteration here, this dice value was a 6. And so then in the next iteration, dice was actually equal 6. And so then the condition is no longer true and the loop stopped. And let me actually write one more line of code here in which we can say if dice is 6, then log loop is about to end. And so this way we can know when a 6 happened. And so the very first thing that should ever happen here in this output is this, right? Because then when the dice was 6, the next iteration will no longer run. So let's do that. And indeed, so we get 1, 5, 4, 1, but no 6. And then loop is about to end. And so the dice was 6. And so this condition was true. And so we saw this log to the console. And then in the next iteration, again, 6 equals 6. And so the loop finished. Let's try some more times. And of course, it works. Oh, and now we get the situation where the first dice ever was a 6. And so the loop never even started. And this was the situation I was waiting for here. So when dice is 6 right away in the beginning, then of course this loop will have exactly 0 iterations. It will never start. Okay, and so the conclusion of this is that the while loop does really not have to depend on any counter variable. So whenever you do need a loop without a counter, you can reach for the while loop. So basically that happens whenever you do not know beforehand how many iterations the loop will have. So in that situation, the while loop is the right tool for the job. And that's exactly what we had here. So we had no way of knowing how many times we would roll a dice that's different from 6. Now, on the other hand, when we do know how many times the loop will run, that means that we're going to actually need a counter. For example, when we want to loop over an array, we already know how many elements that array has, and so we know how many iterations we will need. And therefore, the for loop is usually the right choice to loop over an array. All right, and with this, we kind of finished the JavaScript fundamentals. All there's left to do now is for you to complete the final coding challenge of this section. And here goes the final coding challenge of this section. And in this one, let's improve the tip calculator that we created earlier, but this time using loops. So here is what I want you to do. First, create an array called builds, which will contain the 10 test values that we have down here. Then create empty arrays for both the tips and the totals. And so these arrays should be called tips and totals. And if you need more details about this challenge, you can always go back to the code of the previous version that we wrote of this. Then in number 3, use the calc tip function that we wrote before. And so go back to that challenge really and copy the function from there. There's no need to repeat the same code. So use that function to calculate both the tips and the total values for every single bill value that is in the builds array we created in number 1. And to do that, of course, use a for loop, just as we learned over these few last lectures. And my hint to help you a little bit with this in case you need it is to call the calc tip function inside the loop and then use the push method to keep adding values to the tips and the totals arrays. All right, so that's the basic challenge, and hopefully you can solve it even if you need to consult the code that we wrote earlier. That's absolutely no problem. So there's no need to memorize anything. All you need is to understand. And so if you understood what we did up until this point, you should be able to look at the code that we wrote and then change that in order to fit this challenge. Now, if you want to challenge yourself even more and basically push what we learned to the limit, then I have a bonus question. And here I want you to write a function calcAverage, which will take any array called R as an argument. And this function will calculate the average of all the numbers in the array that it received. Now let me tell you that this is a very difficult challenge for you at this point, because we haven't done anything like this before. Okay? So if you don't want to get frustrated or something, then there's no need to try this one. You can just watch the solution at the end of this video. But if you still want to attempt how to do it, here are the steps how to solve it to make it a bit easier. So first of all, you will need to add up all the values in the array that the function receives. And to do that, you start by creating a variable called sum and set it to 0. And then you will loop over the array using a for loop. And in each iteration, you will add the current value of the array to the sum variable. And by doing this, you will end up with all the values in the array added together. And then to calculate and return the average, all you have to do is to divide the sum that you just calculated by the length of the array, because that is the number of elements. So for example, if the array had just two values, like 10 and 20, we would add them together, they would be 30, and then divided by the number of elements in the array. And so that would be 2, and so the result would be 15. Okay, that's how you create the calcAverage function. And then I want you to use that function on the totals array. All right. So basically, I want you to calculate the average of all the total values of the tips plus builds. Okay. So again, don't beat yourself up if this bonus one is too hard for you. Anyway, good luck with this one, and I see you here again in a minute. Okay. And let's start by grabbing the calcTip function from earlier. So that should be here. Okay. And that's why we keep all the code in one neat file like this. Next up, we create the builds array. And this one has quite a number of values, but we can just copy them. They're already almost in the correct format. So no and, but a comma. Then we create the empty tips and totals, const tips equals an empty array, and const totals another empty array. And now is where the magic starts. So basically where we will calculate the tips and the totals. So that is question number 3. So use calcTip to calculate tips and total values. So essentially what we will do is to loop over the builds array and then fill up these two arrays. So for let I equal 0, and we want this to run while the counter is less than the length of the builds, which is 10, and so the last index is 9, and so that's the last element that's going to be taken. And now in here, let's start by calculating the tip and store it in a variable. So const tip is equal, and now we're using the calcTip function. So we call it using parentheses, and now we need to pass in the bill value. And what is the bill value? Well, it is just the builds array at the current position. And now you might wonder why I am able to declare this tip variable here as a constant. Am I not changing it in every loop iteration? Well, actually that's not what happens. Actually, in each iteration, a new tip variable is going to be created. So we're not mutating, we're not changing the original tip that we declare here. In each iteration, we will simply create a new one. And that's why we can use const. Anyway, now we have the tip calculated, and so we just need to push it into the tips array. So tips.push, and here the tip. And finally, we need to push into the totals. So totals.push the tip plus the current bill. And we already know that that is bills I. Okay, and that's actually it. Now you could have done it in a different way. For example, without this variable here at all, you could have just put this code here and here. But then you would have calculated the value twice, and that's just not necessary. We just calculate it once, and then we use it both to push the value into the tips and into the totals. Okay, and now as always, let's check all the 3 arrays out in the console. And whoa, that's a lot of numbers. But just by quickly looking at them, everything looks correct. Great, that's really great. We basically just did the same as we did in the previous version of the challenge, but this time we did it using a loop instead of manually creating the array by calling calctip with builds 0, 1, and 2. So that's what we did in the previous challenge, but this one is a lot better. Because now, no matter how many builds we have here, the loop will take care of all of them at the same time, basically. Okay, so that's the basic challenge. I hope you arrived at the same result that I did, no matter how you solved it. And now let's go for the bonus here. So we're writing a function called calcAverage. So const calcAverage. And once again, I'm using a function expression here, which is my favorite kind of function, I would say. And as we said, we will receive an array, and any array here will work. So once again, we're building a generic function which does not care what kind of values it's going to receive. It can receive bills or tips or scores or heights or masses or whatever, really. It doesn't care what the values are. And that's also why I gave it this generic name. So it's just calcAverage and not, for example, calcAverage totals. Let's now do what we say, or what I say here in 4.1, which is to start creating a sum variable that starts at 0. Then as we loop over the array, we will keep adding the current value to that variable. So this time it needs to be a let, because this sum will of course be updated as we loop over the array. And now all of this is pretty standard at this point. So equal 0, I should stay below the array dot length. And so this time array is simply the array that we're receiving in this function. So it's this parameter. And now, as I said, as we loop over the array, we will keep adding the current value to the sum. So what I mean is sum will be equal the current value of sum plus the array that we received as an input at the current position. And that's it. We're just missing here the increment of the counter, but that's easy to fix. And this one here could be even more condensed. So let me just copy this one and comment out the original one, because remember that we have a more shorthand operator in JavaScript, which we can use when we want to update a value. So instead of sum equals sum plus, remember we can write sum plus equal array I. So this one is exactly the same as this. So if you prefer, you can write just this version, but this here is going to do exactly the same thing. Okay, and just to see if this works, let's actually test this now by logging only the sum. So console.log sum, and now again to test it, I will just call the function calcAverage with simply an array of sum values. So 2 plus 3 plus 6. And we know that this will be 11, right? And so now we can test this function here just to see if this first part that we just wrote works. Let's see. And yes, we get 11. And so this logic here is correct. So we got this array here into the function. Okay, and so R is now 2, 3, 6. And so that's the array that we're then looping over. Okay, so we end up with a sum. And now what we want to return is simply the sum divided by the number of elements in the array, which remember is r.length. And that's it. You can now get rid of this, but now we need to log the result to the console if we want to see it, because this function here now does not log it, it simply returns it. And remember that that is a big difference. So we know that the sum of this is 11, and 11 divided by 3 is something like close to 4. So we could change this here to 7, then the sum would be 12, and 12 divided by 3 is 4. And so then we can make sure that this function works. So it is 4, so great. This means that the function now works. And so now we can use this function to actually calculate the average total. And so here we simply use the totals value that we already created before. And that's it. So the average total value of all our builds plus tips is 275 and 19. And let's actually do the same with the tips themselves, just to get an idea of the kind of tips that were paid here. So the average tip is 42.89. Hopefully that part here was not too confusing. But if you go slowly through the code step by step, you will understand it. All right, and with this, we finished the complete JavaScript fundamentals. So we made a ton of progress here. So congratulations for making it this far. Great job, really. However, as you know, we are really just getting started here. There is so much more to learn. And actually in the next section, we will quickly configure our VS Code editor a little bit better and also set up a better development environment. So that's going to be super useful for writing code a little bit faster. And I will also teach you some developer skills that every developer should really have. But as always, before moving on, make 100% sure that you understood all these fundamentals from this section and the previous section. So if you want, you can redo the challenges, or you can come up with your own small problems or ideas to solve. And by doing that, you will reinforce all these tools even better and ultimately become a better developer faster. Then, when you're really ready, let's together move forward.